and it's differentiates everything else, so it would probably
Yeah, but it doesn't work.
Doing right.
Yeah, once you sort out the microphone, we connect another system.
Right, because they do have the button bar, and we will start a little bit later because the keynote speaker is actually arriving right now, so that's a second. So we should just tell people that we will be able to.
I think in the other room, so I have one point of view as a pointer. The mobile phone is here, and you have to go to a room with the system stuff. So it should be special in
Yeah, but I'm not really sure if I'm going to be there like the whole time.
I'll be here all the time.
Yeah.
But somebody needs to be there full time. So either you or Sean. Somebody who will run this and teach you how to run those communications. I'll give you a couple of things and how to do shots. Charles knows you do this.
Okay, so I will just give it to Charles.
So 100% here, 100% one of you.
Got it, will be there. Okay.
Charles
so
is
just
taking
a
it.
bit of the later because the next speaker is.
Yes.
I'm actually going to Charles to discuss who will be right. Okay.
You want to set up something or do you have USBs? If you have Sorry, so we are slightly late, but usually we put this opening session as a buffer actually for the so opening session is begins now.
It's less of fancy.
Okay, well, we're setting up the call. Good morning, everybody. Thank you very much for coming so early. My name is Khalid Al-Bigaim. I think by name you will know me already. So this is the face behind the name. I hope you are not disappointed. So it's great to see you here. Ngmast has been really our journey from 2007, where we started this conference in Cardiff, and now it's the 8th. It's hard to believe, but it's the 8th episode of the conference. The journey has been really fantastic. We had the first 3 Ngmast conferences in Cardiff, where I work, and we started the conference there. Then we went to the Middle East, to Jordan, then back to Cardiff, Paris, and then Prague, and now back to the UK, to Oxford. We are very, very proud that we managed to maintain the same standard for the quality of the conference. We received over 92 submissions for the conference. We accepted 52, and there was a workshop ITAS where we had. So overall, the acceptance rate we try to keep around 50%. And these times when you all know that there are so many conferences, and it's easy to get acceptance in some of the conferences, we try to maintain the quality. We maintained the support of IEEE from the first conference, and it has been continuously with us, and this also shows that we kept the quality at this level. Of course, thanks to you, your papers are making the conference. We expect more people. We expect about 60-65 participants, but of course it's too early. And for some people finding interesting places this morning to see before the conference. But again, one of the key aspects of the conference that we always try to make it not only as a forum for you to come together to show your presentation, but also as an opportunity to listen to distinguished keynote speakers. And this morning I'm very pleased that my friend and my colleague Professor Rahim Tafazoli accepted the invitation to give the talk. I think I've known Rahim since I arrived to the UK. I arrived about 2000 and probably met him in the same year or a year after. And it is an amazing journey that he has done, establishing one of the most established, most respected research centers in Europe in wireless communications in University of Surrey. He's, of course, leading this center for wireless communications. Recently, as always, he is ahead in proposing and establishing centers for the future. So Rahim suggested and established the Center for 5G Innovation, again based in Surrey, in collaboration with a large number of leading businesses and industries in Europe. Of course, he has been granted the fellowship of the World Wireless Forum for his contributions to wireless communication. Of course, it's needless to say, publishing huge amount of papers, over 500 journal, conference, and keynotes. A fantastic view of the wireless world, and I hope that Rahim will share this with us today. Rahim.
Thanks, Khalid. I didn't know that we knew each other so long. Time passes very quickly. Good morning. I would like to share with you our vision of what we believe that 5G or next generation system is, and which is, since we started this innovation center in mid-2012, it was the first one in the world. I think more or less the whole vision globally, when you look at it, is converging, and it's more or less we are saying the same thing. But we have some distinction between other international initiatives, which I hope I can highlight those here. Okay. I think the title says quite a lot. I know when we've gone to 1G, 2G, 3G, 4G, it's always been the first generation or second generation mobile communication and cellular system. The way that we see 5G is not just mobile cellular system, it's a broadband communication plus other networks, which I will explain in a minute. So let's start with the history of the mobile communication. 2013, mobile communication was celebrating its 40th birthday. And we've gone through many generations with different types. And this morning you heard on the news the iPhone 6 and iPhone 6 Plus is coming out. So much functionality, as well as iWatch. So we've gone through a really a long journey of the first one. Used to be something like portable in a case. Probably most of you are too young to remember. I think Khalid and I will remember that we used to carry it in a bag on the shoulders, and that was associated with the yuppies, we used to call them, in the city. Normally, they could afford it. So, at the moment, in developing economies, which 109 countries were part of the statistics, and as well as advanced economies, so 35 of them. The number of mobile phone cellulars per 100 population is 81%, and in advanced countries, 110%. So that means effectively one person, some people have more than one phone. And now broadband is catching up. And if you compare all this with only internet, fixed internet users, which is altogether comes about 2 billion worldwide, whereas the mobile users, which is a broadband or a mobile voice and narrowband, is about 5 billion users. So wherever there is no fixed infrastructure, the mobile plays an important role. And as I said, this smartphones is reducing this gap between the smartphone users and broadband services. So, what has the mobile communication done to our life? That we need to step back and see what, since the beginning of the early 80s and up to now, and it has fundamentally changed the way that we see the world. For example, it has changed our life and society from an analog type of society to very much digital individual society. And it has changed from unconnected world to a global village of fully connected. And it has even changed the way that we celebrate and we enjoy ourselves. Many years ago, we used to go to concerts and dance. Now we go to concerts and always film and SMS and Twitter and other social networks. That's all we do. And what's going to happen with wireless connectivity in the future? Our cars will be connected, fully connected, and we don't have to have a driver in a car. And one of the main implications of this one is it will change the transportation infrastructure. If we have a car which is fully controlled by the network, do we need traffic lights? Because everything is going to be controlled by the network. So, communication is very important, not only our private life and professional life, but is important to a country's economy. And what we think the future is more about connectivity. So things which are important has to be connected. And connectivity provides communication between people, as well as that connectivity is to support controlling some devices and monitoring other devices. So it's about communication and control. Like controlling the car, controlling the traffic lights, controlling the smart metering, which is subject of the news today on the radio. So towards a fully digital economy and society, and will help, communication will help to modernize the aging industry. Transportation is more than 100 years old. Energy networks, manufacturing, health, and etc., towards smart homes, smart cities, and smart countries. In fact, eventually. So for this, the telecommunication infrastructure as a national critical infrastructure, together with other national critical infrastructure, will converge. Will not be supported by one network, but will be connected with each other, and through internet and as well as communication network. So the communication network could become a super national critical infrastructure, which is very important to a country's economy, country's security, or country's prosperity, and everything. And it will be connecting many devices for education, for purchasing, for smart fridge, smart homes, smart cars, smart buses, smart buildings, and smart health. And it's been said that 2010, 14 billion devices are already connected. And that is only 1% of the total things that could have been connected so far. So there is a room for another 99% of other things to be connected. And that is what we believe that 5G, even 6G or 7G have to bring it out. Or 5G will lay the foundation, and the future generations networks will build on that over the time. So if you look at, you can see the top bit, that is UK industry benefits of the big data when you have this connectivity between all these different manufacturing, retail, central government, health, telecommunication. In 2011, the total value of this connectivity and the data is generated from all this connectivity. 25 billion, it was estimated to only UK economy. And it is expected that will be nearly 10 times higher by exploiting such a big data generated from all this connectivity. Of course, the data generated itself is useless most often. So it's very important that data generated, it can be integrated and interpreted to provide a new service. And that connectivity of the data, location dependency, the time dependency, and the value of the data, when they are integrated, becomes more meaningful and more useful. And that data connectivity has become very important. So now I'm focusing on the other aspects of the 5G, which is the mobile broadband. Because any smart city or smart home or a smart country needs to have a broadband communication as well. So what is happening is been reported many times that the traffic in 2015, mobile data traffic, not the traffic that goes through Wi-Fi. If the traffic goes through Wi-Fi, is considered as a fixed traffic. So mobile using the cellular system in 2015 compared to 2010 was 26 times. 2020, if it goes at this pace of the growth, will be 1,000 times. And if it carries on at this pace, by 2030, will be 1 million times. The volume of the mobile data traffic. Obviously, these 1,000 times or 1 million times, they don't translate directly. They translate directly, but it's not the same value as the capacity of the car. So we have to be careful when people talk about huge amount of data, volume increasing 1,000 times, therefore we need 1,000 times capacity. This is wrong. But the system that we have to develop has to be with us, and at least until 2030, 2040. So we need to design a system for this sort of mobile data volume, not this value here. So where this huge amount of mobile data volume comes from? One of the reasons is the internet is becoming very complex, and the web pages are very complex, and they are mainly video and high definition content. The content becomes richer. So the average file size of web is about 10 megabytes, and 99% of most of the bytes transferred is the video. So this is one of the reasons. Another reason is the popularity of the smartphones and tablets and connected to internet as well as the 4G and providing the data communication as well as the social networking. That's the amount of, I was surprised to see how much the number of tweets, for example, here is generated per minute. And obviously this one was about maybe 18 months old, the statistics. So what is the implication of all this mobile data traffic on the capacity, which I mentioned earlier? So we look at the data was reported, the statistics by Cisco. That's 1,000 times, that's where it came from originally. And we mapped that one to UK population, UK number of mobile users, and then we mapped that one and scaled it down to London. And we wanted to see what would be the increase in traffic in 2015 and 2020. And do we have enough resources to cope with such an increase in capacity? So in 2015, in dense urban environment, which is the center of London, which is a typical capital city for most of the advanced economies of Western countries, Tokyo, including Tokyo, New York, and etc., etc. We require about 2.8 gigabits per second per kilometer square of capacity. And by 2020, if this projection is correct of the traffic, it will be 53 gigabits per second per kilometer square. So what is important to understand the significance of this is the ratio between these two. So since we are talking about capacity, now we can easily and correctly translate this one into the bandwidth the radio spectrum we need. The ratio between these two is about 19 times. And 19 times, if the way that we have come about 4G and 3G and 2G and etc. to increase the capacity, increase the speed, we proportionally increase the amount of spectrum that we need. So if it is 19 times, if you use the current technology of 4G, for example, we need 19 times more spectrum. If you want to keep the same cost for the network, you just pay for this. We do not have 19 times more radio spectrum. We don't have 10 times, we don't have 5 times, we don't have 23 times. The best we could wish for is 500 megahertz of bandwidth we have for mobile, we have another 500 megahertz. That's the best case. And we'll be twice as much. So, this is one of the challenges that we see that 5G needs to come with the new technologies, not evolution of what is 4G and others, in order to cope with such a huge demand. Obviously, most of this calculation is based on the traffic projection that has been reported widely by Cisco and others. So we are not in a position to dispute that, argue with that. I don't know if it's right or wrong, but most people seem to be accepting. So it's an order of 1,000 times or order of 100 times. So we look at 4G, LTE and LTE Advanced. And again, we apply two things. We look at all the transmission modes, which is in 4G. Very simple single user MIMO 2x2 with joint processing and comp 4x2. Very complicated. This is the traffic demand gigabits per second per kilometer square over the time. And this is the cell radius or densification of the cells. We start with cells of 300 meters and reduce it to 100 meters. Because densification of the cell and reuse of the spectrum is another way of increasing the area capacity. If you don't care about the cost, there are more ways. So we look at the impact of the cell densification and the impact of using advanced radio techniques to increase capacity. By 2020, the first number refers to the simplest, the most complicated technique, and the second number is the simplest transmission route. So the worst case with 300 meter radius cells as single user mono 2x2, we need 6 gigahertz of bandwidth in central London. The best case, if we can afford going for a costly one, and we go to advanced transmission techniques, we need about 300 megahertz of bandwidth. And that 6 gigahertz or 300 megahertz of bandwidth has to be shared between all the UK operators. So we are not looking at dividing, sharing the how much. 6 gigahertz and 300. Unfortunately, below 6 gigahertz, which is most of the mobile broadband are, there's only 6 gigahertz of bandwidth. You can't do anything about it. So either we take an easier option, and go for very high frequency bands, where there is lots of the spectrum, there is no technology available, proven technology. Cells will be very small, the cost of the cells will be very high. All we need to look at very advanced techniques in order for the radio and revise everything that we've done for 4G, and in order to come with this sort of capacity required. So, many people say, of course, Wi-Fi will save us, because we have Wi-Fi, we have 11G, 11AC, 11N, and etc. And there's a huge amount of spectrum there, and we can do offloading using Wi-Fi. So we look at the cellular deployment of Wi-Fi, assuming that Wi-Fi is used in a contiguous coverage and with different density of access points. For example, 1,000 access point Wi-Fi per kilometer square all the way to 8,000 for the deployment. If, for example, one organization deploys all the Wi-Fi for us, which is the planned one, it's a blue curve. If Vodafone deploys their own Wi-Fi, O2 deploys their own Wi-Fi, Philips deploys their own Wi-Fi, and BT deploys their own Wi-Fi, the capacity goes down. That's unplanned. And as you see, as the access point densification increases, the capacity increases, and then after that will decrease because of the interference. And if you look at very closely, when we have high density of the access point, this is intersite distance, so that's distance between the center of the two cells. About 50% of the radio spectrum is used for signaling overheads, TCP and NAC, and other 50% is only used for transmission. So it's hugely underutilized radio spectrum in Wi-Fi technology. Of course, what I presented here is 11G. We have the results. It follows the same trend for 11N and 11AC is the same. So when we put the two together, the cellular densification of the cells, 50 meters cell radius to 300 meters, and all the transmission modes, and do the offloading through Wi-Fi in a sort of highly dense environment. The traffic demand is a blue curve. The effect that Wi-Fi has, densification, is reduce the traffic demand by this much. It's not that much. And this line here, it says LT at 50 meters cell radius. Oh, sorry, 25 meters cell radius, because 50 meters is intersite distance. So if you look at this picture, obviously we have only 40 megahertz, which is typical bandwidth per operator. It looks like by 2016, 2017, in the best case, we're going to run out of capacity, even with the LT, with 4G systems. So these are some of the reasons that we started researching on 5G. And we are looking at the radical approach. Some people call it more revolutionary approach. Okay. We want to see what we can do on the radio side, on the radio access network architecture, as well as the fixed network architecture. What is possible to be done? And we are not banding ourselves to evolution for 4G or FDM or legacy system or migration path and all that sort of thing. And in 2012, with 8 industry partners that we had, we said, okay, let's start with 4G, 5G. When I phoned them up and I said, let's do that, they said, you're crazy. We don't have 4G in UK, and we don't even have a 4G license in UK yet. Let's start working on 5G. And then when we explained everything and discussed in more details, said it's not a bad idea. Let's start on 5G. And now we have about 15 partners. The Ofcom is very important, which we decide or regulate on the radio spectrum. And we have some partners which is not familiar in a mobile environment, like BBC, for broadcasting. And there is a good reason that BBC is there as well. So, is that the right time to start 5G? It looks like every 10 years on average, the new generation system will come. This is the first generation system. And what is important is the time between generations seems to be shrinking. About 12 years, 10 years, 8 years. And if you follow this trend, we believe that 5G should be available in 2020, 2021. And should be with us by until 2040, at least. And most of these systems, they do not replace previous systems. They tend to coexist with previous systems. So far, only the 1G has been taken out of the circulation. Everything else is working with each other. In future, one of these could be switched off. Could be. But they tend to coexist with each other. So, when the system is going to be available by 2020, normally it takes about 6, 7, 8 years to do standardization and research and standardization. So if you work it backwards, even us, we were late. We should have started 5G in 2011, not 2012. So, what is important? People say, what do we want 5G? Not average people on the street, for example. They say, what do you want 5G? You cannot give them that we have this problem with the capacity, etc., because they don't understand that. So what is the applications they normally ask? And everything on the internet, low data rate to broadband. Everything on the internet is important. And up to 4G, we always design the network for a specific service. And we always got it wrong. When we designed 4G, nobody knew anything about YouTube or social network. And the same applies to 3G. The only thing that we got it right was GSM. We designed it for voice. That's it. So we should not design the future system for any particular application. It should be flexible, it should be robust enough from the national critical infrastructure point of view to support all the services, low data rate, all the way to broadband, high integrity, and low latency, and etc. So what we say in 5G Innovation Center is, we say in one sentence, we try to come up with a system which is flexible enough and it's scalable enough that it always provides sufficient rate. What the rate that we will require to users in order to give the user perception that they are in an infinite capacity environment. As you can see, we are not talking about speed here. So we are not differentiating 5G from 4G and previous generation system by only speed. Some people do in the world. They're talking about 10 gigabits per second minimum. But when you ask them, so why? They say, well, it has to be 5G, it has to be higher speed. We are not doing it that way. It will be higher speed for good reasons, which I will explain later. But we are not starting with the highest speed first and then say, okay, what are we going to do? So, let me see the time. 20 minutes, okay. So what I'm going to do, because we are scientists, we are engineers, when I said infinite capacity, you may say, Professor is gone crazy in his old age. How can we have infinite capacity when we have finite resources? So that's the question. Can we have infinite capacity? Or at least perception of infinite capacity. So I'm going to entertain you with some animation, but before that, I want to show you some maths. It's very simple maths, it's not difficult. I tried this last night and it wasn't doing. Anyway, we started in a cellular system with a channel capacity limit, which is from point to point, and which is point to point capacity, bits per second per hertz. When we adopted this one for the cellular system, the capacity, we reuse it over space. We use it over space, and that's the concept in a cellular system. So channel capacity times space gives you the actual capacity. Okay? So we are limited, if you want to increase the capacity, we are limited with 1 degree of freedom, assuming we have a fixed amount of the spectrum. The only way to do it is by reducing the capacity over space. Only 1 degree of freedom. This thing is... Yeah. Anyway, so what 5G, that's not good enough. Doesn't give us enough degree of freedom. And what we want to do is what we have in 4G, we introduce new term. And this new term is here. 1 over T reuse, time between resources that we reuse. Mathematically, if this time to T reuse goes to 0, this capacity will go to infinity, mathematically. But we don't want it to go to 0. We don't need it to go to 0. Because as far as the user is concerned, if the time between reuse is fast enough that every time I want capacity, I receive the capacity, to that user, this time is 0. So what we have to do, we have to combine the actual engineering, like channel capacity limit, with perception of what user wants, which is not actual scientific or engineering approach. And that's what we've been doing since generation 1 to generation 4. All communication systems we have been designing. Now we need to bring the user into this equation. So what the user wants. And the way that I use my mobile phone, for example, is very different from the way that my kids use it. And the services they use. So if this T reuse goes to 0, T reuse approaches qualitative experience the user has, and therefore we achieve effective. Okay, let me give you an animation graphic interpretation of this. This is not anything new, this perception. We use it in every day in our economy, especially in the capitalist economy. Assume there are these 10 users are sitting around the table, and there is one pan between them, and they are trading with each other. This pan goes around here. They are trading between each other. And if this trading goes faster and faster, it has its own mind. It goes faster and faster and faster. There's a time window for each user. They think that they have a pan in the pocket all the time. Effectively, this table, think there is a 10 pans on the table. The actual money is 1 pan. Actual money is 1 pan. Actual capacity is the Shannon capacity. Perceived money or perceived capacity is different. And effectively, that's the way our economy works. You may think that you have some money in the bank, but that money is going around. Unless you put it under the mattress and you sleep on it, you take it out of the circulation. Otherwise, we are sharing all these resources and the wealth, and everybody feels that they have X amount of money in the bank here all the time. But the actual money in the stock market or in the economy is a lot less than that. And when we had this the financial crunch that we had, and etc., the problem was this pan, the circulation is slowed down. That was the reason. And that's why banks were not lending enough money to speed up the wheel of the economy. And that's why everybody started realizing how much is the actual money in the economy. So it's the same thing. This 1 pan is the capacity in terms of the communication. It has to go around fast enough so everybody, everything they want, whether it's a licensed band or unlicensed band, license extend or satellite band or whatever the band is, they should be provided. If the circulation is too fast, cannot do it. In order to provide that perception, you need to throw in an electron. So that needs more spectrum. So it is circulation as well as more spectrum. You need to do. So this is the best analogy I could find. One night I was sitting in my office and I said, I'm going to show this one because when you talk about infinite capacity to engineers, people say, no, are you breaking law of physics? So the research that we are focusing on is 4 areas. We are looking at high capacity techniques, very low energy efficiency, very low energy consumption, power consumption. The delay, latency is very important, I can explain that. And the network has to be intelligent for that coin to go around. Well, I don't know, you use 4G? Sometimes I use 4G or even 3G whenever it's available, especially on Saturdays when I go with my wife shopping. I try to walk behind her and look at the football scores to see what is happening. And she turned around and she said, "Are you still on your phone?" And say how long it takes to download the page, the result. The latency is huge. So this is for normal application. If you want to control the traffic lights in a driverless car, the latency, the delay, has to be substantially reduced to what we have now. And we know it very well. So there's some critical mission applications which require very low end-to-end latency. And some of them, and in general, the latency in the mobile network has been reduced. So, the way we are approaching this 5G, based on this always sufficient rate, is we look at the end user requirements. We try to understand what is qualitative experience. We don't know. We are trying to find out what it is, how you measure it, how you implement it. Network. And it's communication for human to human, human to device, and device to device. So unlike 2G to 4G, which were designed for the end device, so we are going to design 5G for end user. We're going to focus on area spectrum efficiency, not linkage. Spectrum efficiency. We look at energy efficiency, we look at the latency. Latency, we look at it both ways. Look at the end-to-end latency at service level, and we look at the radio. Most of these advanced techniques I mentioned in 4G, you really cannot exploit the full capacity, the gains they offer, because the delay on the radio link is too long. Because most of these techniques operate on feedback loop. By the time you receive the channel state information and you want to do some pre-coding, whatever you want to do, the channel has changed already. In 5G, we start with the high density cells and then go to macro cells. 1G to 4G, they always started with the big cells and try to scale it down. We're doing other way around. We do very high density cells and then which is scalable for macro cells. But because we're doing everything from the user's perspective, the user doesn't care. The service they receive is from broadcasting, from cellular or Wi-Fi technology, because all of them provide voice, video, and audio data. As long as it's cheap, what should they care? And it's reliable. So why do we distinguish between licensed and licensed etc.? So 5G should operate on all these bands. And we try to utilize the big data in telecommunication. There's huge amount of data available on the user device. Huge amount of data is available from the radio. There's huge amount of data available on the network, which can provide valuable site information. I will show you one video, if you have time, about the way that we use the data in a mobile device, smartphone. Obviously, coverage we want and capacity. We don't need high capacity everywhere, but we need contiguous coverage. So we need different cell size. We need big size, cell size for low density environment, and we need small cells for high density environment. And we are approaching this research in two major research areas. One is intelligence in the network and the exploitation of that, to understand the content, user and network context information, and then we use that to distribute the capacity over time and space and frequency. I think that's good. So many people say, do we need a new radio air interface? Yes, we do, for 5G. And the objective is not linked spectrum efficiency to specific areas, because we have reached more or less the channel capacity limit with 4G. What is important is the area spectrum efficiency. We need to reduce the signaling overhead substantially. Most of the signaling architecture in mobile is the legacy that we have inherited from GSM. We're still adopting more or less the same signaling architecture. We're 25 years old. And whether OFDM is suitable waveform, no. Because when we start with the high density cells, we want to minimize the management, the planning management. We don't want to synchronize the cells in time and subcarriers in frequency very accurately. And OFDM, we need to do that, time and frequency control and synchronization. Ideally, you want to plug an access point, a small cell, and just use it, and it has to work. So OFDMA is not a suitable waveform. So we need to look at other waveforms. Most of the signaling is in mobile system is controlled by a network. And we want to divide the signal between network and the device. So that's what we call it distributed MAC, or we call it MAC. It has to work on opportunistic use of the spectrum, license and license extender. So that's why the device itself has an important role to do spectrum sensing and spectrum sharing. Energy efficiency has to be very high. This affects the spectrum. Whatever we do, we are not going to get a nice contiguous piece of the spectrum for mobile. It's going to be highly fragmented. So the waveform has to help us to do efficient aggregation of different parts of the spectrum. We are looking at full duplex radio. We transmit at the same time, the same frequency. Very low latency on the radio side. And this low latency on the radio side maps into the higher speed. That's the only reason we think that we need higher speed. And it has to be scalable, that it can support low data rates, not only the broadband. Okay, let me just go this one. I think that's okay. One of the areas when we have high density of the cells, if they cooperate with each other, they form a distributed massive mind system when they have a cooperation with each other. And And this scenario, the interference is a good thing. This MIMO is good for exploiting interference. Just to show the effect of that, this shows the curve. When we densify, this is intersize distance, the cells from 500 meter to 100 meter, the capacity increases like this. When we have full cooperation and exploit the interference, the capacity increases this way. This is a theoretical limit capacity. And we try to achieve something in between. Energy is very important. If this is the pi, the total energy used in the network, the green one shows when the base station is in a standby mode. They're not, for example, at night, the amount of energy used. The red one is the energy used by signaling only, and the yellow one is energy used for transmission of the data. And if we increase the volume of the traffic to 1,000 times, 1 million times, the size of this cake will increase. The total energy consumption. And we cannot afford doing that. So we need to reduce this energy, and so that when we are in a standby, at least we don't use any energy. And we need to reduce the energy used by signaling as well. So, the target for 5G, as I said, is not the speed, but it is bits per second per meter square, the area capacity. How many bits can we support per joule of energy? A latency, end-to-end, and over the air. And we really need to understand what is quality of experience. So something that we can measure and we can implement. For this, in 5G Innovation Center, we plan to start with 4G advanced network on our campus. This is a simplified version of the testbed that we're going to have. It's about 60 access points and 3 microcells over a 4 kilometer square radius, and connected by fiber optics as well as the wireless backhaul. And it will be connected to Vodafone test network in Newbury, as well as BT and EE, and doing some initially 2.6, next 3.4, and then the magic band, as well as the 5G technology that we can test in this environment. Hopefully we'll have the first 5G testbed in the world in UK. Right? And the plan is to have this 4G advanced by April next year, and then we gradually modify it to 5G over time. So 2017-18 is our wish list, is ambition. So we're doing a lot of research, performance evaluation, simulation. We do some emulation in the labs, and then we take, when we have confidence in some techniques, we take it outside to the test bed. And at the same time, 2016, middle of 2016, some people say probably towards the end of 2016, the whole process of the standardization for 5G will start. And the plan is by 2020, 2021 will be commercial, will be available. So it is not such a long-term, far-away system. Just to summarize, 5G is all the national critical infrastructure, including broadband, new business models. The way that we approach 2G to 4G is not really sustainable. We cannot carry on doing and increasing the bandwidth as we do. We need to look at the perceived internet capacity, latency, energy efficiency, scalability, reliability, and etc. These are extremely important attributes of the 5G. What we have set for ourselves is we're going to make 5G 100 times more energy efficient than LTE 4G is. Availability 99.9%, 5 nines. Machine-to-machine communication, broadband communication, And it will be, because of the latency, it will be 10 times faster than 4G. It has to support digital terrestrial TV as well. And some more intelligence in the network. So I got one video. I think it shows the way that I can go back to my. It effectively shows the intelligence that we can extract from the data we have in a mobile phone about the user, without user interfering. Let's go to the USB. Just to take it? No, just to this other file.
We've created UDirect technology that allows us to estimate which way a user is facing, regardless of the position of their mobile device or its orientation. In addition, UDirect is able to recognize the position of the device in real time, knowing which way a user is facing.
Yes, this invention is just using
We've
the
created
data in
UDirect technology that allows us to estimate which way a user is facing, regardless of the position of their mobile device or its orientation. In addition, UDirect is able to recognize the position of the device in real time. Knowing which way a user is facing and where the device is placed with respect to the user gives valuable information for the provision of mobile services and applications. Some of the applications of this technology include positioning applications for indoor or outdoor environments, dead reckoning, real-time user tracking, advanced human-to-computer interaction (HCI) in smart environments, real-world gaming, context-aware management of device functionalities, user profiling for real-world analytics, improved social network analysis, organizational engineering. UDirect technology utilizes only the inertial sensors that are readily available on portable devices such as smartphones. While delivering high accuracy, our solution is able to cope with arbitrary wearing positions and orientations of the mobile device, making it suitable for use in everyday life situations. UDirect achieves this by detecting the position of the device and estimating the user's orientation with respect to both the device and the global Earth coordinate system. This technology has a wide array of benefits in contrast to other technologies available today. These include accuracy, outperforms the existing state-of-the-art solutions, for example GPS-based systems. Compatibility, applicable for any portable device with integrated inertial sensors. Scalability, implementable on off-the-shelf devices as a software and does not rely on any infrastructure. User-friendly, works regardless of the mobile device position and orientation on the user's body. Real-time, provides instantaneous estimation. Energy efficiency, uses only low-energy inertial sensors, 30% more energy efficient than GPS.
this is one of the inventions that we have come up with, and that will be as heart of some of the technology to understand the user, corporate experience, and capture the user context.
We've created UDirect technology that allows us to estimate which way a user is facing, regardless of the position of their mobile device or rhetoric.
Okay. Thanks very much.
Thank you very much. Thank you, Rain. Amazing talk, vision to the future. So we should count on that new type of banks, probably. This is spectrum banks. I mean, your application will go to lend some capacity from these banks in the future. We have some time for some questions. Questions, speaker? Yes, please.
I'd like to ask a question about
the video.
Yeah, the video. Basically, we have some similar implementation for the neural navigation micro lane. And basically, we found that it's very battery demanding. So basically, what I can see in this video is that this kind of process will be continuously working in the device. So how this would affect the battery?
Well, actually, if the question is the positioning, we compare this one with the position advanced tracking, compare this one with the GPS, as you said, is 30% more energy efficient. It requires less energy than the GPS does. So what we are doing, effectively, using the sensors, which is already in the mobile devices, and then the fusion of the information from the sensors is our innovation. And the energy is used by the sensors, which is a high quality sensor, which is most of them are very low quality, cheap sensors. And it doesn't require anything to be transmitted over the line, over the air. Everything is done locally.
Yeah, I understand the sensor does not consume a lot of power, but the processing, continuous processing and analysis of data is the processor typically does not consume a lot of power because it's not always accurate. But for such applications, you need the high accuracy. Probably you are doing continuous kind of analysis for the receive data.
You need continuous, if you want continuous information about the user's context. You don't need to do continuous processing all the time. You know, for example, what you can do when the user context changes, then you can do the processing. But it doesn't change, it should stay in that state. That's one. Did I answer your question?
Yeah. Any more questions? So you said, Ryan, that 5G will need new kind of infrastructure, basically. Would you think that will delay its deployment, even if you are ready technology-wise for it? Because that will be a huge investment. Isn't it a good way to try to reutilize some of the existing infrastructure?
I think it will be, 5G will go through different phases. You know, 5G phase 1, 5G phase 2, 5G phase 3. I believe that for millimetric bands, we need to have 5G. That will be 5G phase 2. And then, but phase 1, we are talking about what we can do in 2020, 2021. And that would evolve also through the phases. And we need a new infrastructure, but the infrastructure, as I mentioned, because we need some areas for mainly the coverage, which is LTE or 4G or 3G are very good. And some areas we need high capacity where the 5G will be very good. So it will coexist with the existing system with 4G. And the 4G has a role, and 3G has a role to play for many years to come.
And I noticed that you mentioned clearly the mission critical services. One of the areas that we work on is how to integrate emergency services mission into 4G. Probably 5G will be more appropriate because 4G has gone now. We can't do too much about what we have. So that's another area where we think that probably
it's a very important area. We've done a lot of work on the machine-type communication using 4G, air interface, and adaptation of that. That's so much huge amount of signal. If you look at the protocol stack in 4G, especially radio resource control, most of these are redundant for machine-type communication. And especially when you want long battery life, and you want low latency most of the time. And we need to design the system with machine-type communication in mind. So whatever we do in 4G, it will be supporting not as efficient.
Yeah, our research, we got it's a 4G is a problem for this kind of emergency services to compete with Tetra and to beat Tetra in point of service. 4G might struggle through this, so 5G might be the platform for that. Thank you.
I said at the beginning that 99% data is video. Is there any kind of optimization that are video oriented?
Any research in the video?
Next generation networks? Because this sounds like something that focuses on these networks. Everything that's passing through video, then somehow it should be taken into account. Right?
Yeah. Well, I mean, we don't research on video coding and stuff like that. On the other hand, the video is HD and Ultra HD and we got 8K and etc. is coming up. And similarly, they're doing look at the compression technique. But what interesting research I've seen on the video is it's very much like taking into consideration the user perception. Quite interesting in order to reduce the amount of video or transmit over the air or the resources. It depends on the ambient light and the way that person is looking and what the person is looking, and only those sort of areas on the device is only high resolution techniques. And it requires a feedback between the transmission rate, compression rate, and what the user is perceiving. And that, they were claiming that they can substantially reduce the amount of the data they transmit. So we need to consider what user expects and what satisfies user. And because most of the compression techniques and video coding techniques, there's not a big major advancement compared to what has happened a few years ago.
Okay, we're running out of time. Thank you very much, Rahim, for the talk. It's great to have you with us. And I know that you are busy and you're up to London now. So thank you very much for being with us. So I have now 2 minutes of your time just to about the arrangements. So the coffee breaks and the lunches will be in the building where the registration desk is. So actually the coffee break just opposite to the registration desk. We are enough time for coffee breaks. Usually they leave 20 minutes. We left half an hour to allow for going down and to back to the rooms. This is room B. Okay, so for the sessions, if you see, we have to split on. We have so many good papers. We couldn't just have one session, although I'd like one session all the time. But so this is room B. Room A, in the booklets, there's a map which of the site, not on mine. Yeah, you have it.
You can see it from here. So
yeah. So the room, there is this is where you need to cross the road, and there are signs. And after the break, I have colleagues from the organizing team to show the way. Once you know it, it's easy, but to find it the first time is very difficult. This is Oxford, and the colleges are here, not like hotels where rooms next to each other. You have to go around. Of course, as I said, we have a keynote in the afternoon as well, after lunch. Lunch, again, in the same building where the registration desk. It's in the second floor in the staff Nanzahir restaurant in the college. Wi-Fi is available. I think you got your sheets with the password. It's an individual password, so please.
And your own works.
Yeah, and your room works as well. Lastly, we have the program also on app. on Android only, unfortunately. So my phone will not, iPhone will not be useful. So you can download the app through a QR code here. So easy to download. This will give you news and updates about what's happening in the conference. So if there is delay somewhere or change in the program, we will notify you straight away about this. And we have a Twitter hashtag. So please tweet. Let's share your views. Tell us and tell everybody what you feel about the conference.
And we are live as well. We are live now.
Yeah, and we are live on YouTube. So the keynote was on YouTube, and I forgot to mention that to at the beginning. All the talk will be in this room on YouTube. So if you miss coming to one of the sessions and you want to watch it, just go to YouTube and you will.
The link for YouTube is available on Twitter.
Yeah. Actually, they know more than I do, as usual. Okay, so we have coffee break, and it will be shorter than others. Let's say 20 minutes of coffee break, and then we get back to the rooms. May I ask the session chair for the...
Yeah, the session chair for the next session, please. I have a session kit for him. So we have a session kit for each session chair, where he has the biography of all the presenters that you have already sent, all of you. And please, all the presenters for the next session, try to approach me in this room in order to upload your presentations.
As well as in the other room, where we will show you that.
In the other room, there's another guy called Charles. He will be taking your presentation. We do that beforehand, and we upload all presentations on this laptop. We don't want to go into the hassle of switching laptops all the time. So just prepare your presentation on a memory stick, please, and pass it to me. I'll upload it here. Professor mentioned everything except the toilets. They are back there at the right hand, and on the other room there will be signs for the toilets. Emergency exits. People down there.
Stairs just in the corner.
There's stairs. You can go downstairs next to the elevator. You can don't use the elevator in case of emergency. And there's no arranged fire drill.
If you hear a siren, then it's okay, thank you very much. So we'll see you in 20 minutes in the room. Thank you.
Are you presenting now?
Yes, I'm presenting the next session.
So you're
The first one and the last one? Yes.
After, yeah. And I know all people by names now, because I've been preparing all the programs. So when you see them,
You know them by heart.
yeah, so I know. And you're chairing the session as well.
No.
Arthur, yeah, we put you to chair one of the sessions, I think.
I didn't receive any information.
We were changing yesterday, and I think we allocated you. I'll check for you now, yeah? And then I'll let you know.
I will go to present and bring the chair.
Not this session, another session.
Okay.
So, Arthur, let's start first by Ahmed, since you arrived first. Yeah. So, Ahmed, which one is yours? This one.
Yes,
Give me the presentation.
Excuse me, I didn't catch. Is this room A or room B?
This is room B.
Room B.
Track B, and room A is just down there.
So what? All right. Thank you.
We copy all presentations, and later on we take your. If somebody asks for a presentation, we don't send it unless we take your authority. I think we need to smooth this. Good live feed that had. Was live on YouTube and I've tested it. You can hear everything and you can see everything. You can ask your family, Ahmed, to watch you while presenting.
Maybe.
Just I'm on YouTube watching now. So this one, yeah? Yes?
Is it live
So
stream?
this is the second one, yeah. So shall I copy what is it? Copy this. Copy
And
two.
are it being recorded or just live?
PowerPoints.
Recorded as well.
So some copy will be available on YouTube later.
Yeah.
This one. Copy. And so, yeah, paste. And this one. Yeah. This one. Copy. Paste. No. This was provided by Oxford University, so I'm not used to the shortcuts, so I'm using one, that's why. No, maybe we can check that thing. Which one? Both. Works? Good. The other one is this one. Okay, great. No. Do you know how long? Each session we allocate 20 minutes, 25 minutes. So you can speak for 18 minutes and leave 7 minutes for questions, or 20 minutes and leave 5 minutes for questions. So we always leave plenty of time for you to go. So now this is the first one. So which one is this one?
The first one is the AR framework.
This one.
Yeah.
And the last one here. They were after each other. I changed them, one at the beginning and one at the end.
Yeah.
That's better.
I get to have a break.
Yeah, you can have a break.
That's good.
And the last one is lucky, yeah?
Yeah.
And we're ready. Just Satish. This is the pointer when you start with the so this is the front one. This is the next eraser on this one. I don't know why. Let's keep it there. Okay. Good. Now this is your player, yeah? Yeah. We'll check if I allocated you chairing the session or not.
You know, using some video and I haven't touched that. The session B2 or the session even yeah, crochet. With this. Yeah, look those things. So I guess for you, just you have a simple plan. You have 1, 2, 3, 4 tables. Skip the time that you have. You start first by saying this is XYZ, and you read this or you take some snapshots of it. It's really good. So easy. And when you start talking, that will start when you organize annoy people about ticket time. Make sure that, for example, 20 minutes talk and 5 minutes question. They will not to exceed that and to manage the time. And manage the questions. If you want to ask a question, make sure you have a question. Ask. Get it? And if you ask, if you try to those which one and they are presenters, ask them to upload their presentation, ask them to approach you, and I'm going to ask them to file them as well, make that decision presently and upload. Yeah. Okay, got it? And the help I'm available.
I might miss something.
Well, I'll be here all the time, so I'll be supporting you all the time, yeah?
Discussion program after this. It's the last thing.
This got up there.
I mean, this
will be the last session.
So it's not, yeah, sure.
There's a keynote, and this is after the keynote.
Yeah, if we go 10 minutes.
That's all right.
Yeah.
I'll be down to the coffee. You want to go to the coffee?
Yeah, sure.
This is going to be this. Now, this is the session. Is there a laptop there? There are laptops. There's a laptop there. Let's go there. Let's go there. Yeah, I know this is huge stuff for this.
share.
Where the gentleman is the right, just down there.
Start here, right? Other option was to stay at none, the one right and the right. Here this afternoon. Maybe stay be present to stay on all 3 days. 2 days. So today and tomorrow. Yeah.
No. No.
So I'm going to give you now the session recap. Just go to Twitter. You will find the link to the video. I was searching for you. This is a session.
Okay, but I'm so am I able to?
Yeah, that's all. I'll help you. So just present the session. This is the presenter. First presenter. This is the skill presenter.
I'm not really able now to do the share.
Are you sure?
Yeah, sorry. Yes.
How are you? That's why it is so fast. Remember the first, second, we were still more on here we are found out you and the rest of the team. I was at Ulster for 2 years and then I left Ulster.
Satish Kumar.
The North Coast. To Belfast. Too easy. Because my colleagues
We found that.
Okay.
Satish, we're waiting for you to start. Sorry for being late, but Dr. Wissam will be chairing the first session. Dr. Wissam al-Mubayin is from Jordan, and Dr. Wissam will be allocating time. We allocated plenty of time for each presentation, so we allocated 25 minutes for each presentation, 20 minutes to talk, and 5 minutes questions. I think that's enough for everybody. If you want to take less time, that's okay, but try to adhere to the limit that we have. One minute. Let's upload this. Yep. Yes.
Good morning, everybody. Our first presentation is entitled World's Augmented Reality Applications in Mobile Web Context, presented by Arto Heikkinen. art making university an MSc degree in computer science and engineering from the University of Oulu, Finland in 2010. In 2008, he joined the Department of Computer Science and Engineering, University of Oulu, as an assistant researcher. In 2010, he became a researcher scientist. Since 2012, he has been a doctoral candidate at the University of Oulu, currently working at the Center of Internet Excellence and pursuing his PhD. Please.
Okay, so once more, my name is Arto Heikkinen, and the topic of my presentation is towards augmented reality applications in a mobile web context. So basically what this paper was about, it was sort of an exploration of the possibilities of using web browser as a platform for developing AR applications in mobile devices. And we explore the challenges also regarding this very new and emerging technology. So why now? Why are we proposing to start developing AR applications in web browsers in mobile devices? So first of all, the processing power of modern mobile devices like smartphones and tablet devices is getting advocate for this kind of augmented reality applications, which traditionally are quite computationally demanding, for example, for rendering the 3D content on top of the view of the real world, and also for the sort of computer vision algorithms that are usually required in augmented reality applications. For example, for detecting some sort of AR markers or tags from the video feed. And the second reason is that modern mobile devices are embedded with multiple sensors, like we saw in the keynote talk. There was this video about determining the pose of the user. So mobile devices have multiple sensors that can be used also in augmented reality applications. For example, the GPS for locating the user, and then there are different sensors for determining the position and orientation of the mobile device, and also different kinds of accelerometers and things like this that are very useful for AR applications in sensing the environment. And also these enabling web technologies are becoming available. For example, WebGL for rendering 3D content in a web browser, and also these new HTML5 standards that enable web browsers to access the sensors of the device directly. And also, for example, WebRTC, which allows getting the video feed from the camera of the device for the augmented reality application to use. And then a little bit about how is web browser as a development platform for augmented reality applications. Well, first of all, the most obvious upside of web browser is that it's a unified platform. So you don't need to write different code for different operating systems and system configurations. So basically, in a world where you have web browsers that are 100% standard compliant, you would only need to write a web application that would then work identically on every web browser and operating system configuration. Naturally, that's not yet the case, so there are always some differences between web browsers and how they implement different standards, which might cause naturally some problems, but that's the vision, so that you would get a unified platform for the application development. And there are also some challenges regarding performance in web browsers, so the performance is not nearly as good as with native applications, which is naturally a problem with especially with augmented reality, because it's a very computationally demanding type of application. And also challenges related to stability, so these latest web technologies like WebRTC are not yet that stable. So we've had some browser crashes while we have been doing this augmented reality research. Okay, so this paper presented a framework for developing web-based augmented reality applications, and here is the API stack of this framework. It consists of different components. So here we have this sensor-based registration and tracking, which is basically a component that provides access to the device sensors like the GPS and so on for determining the context of the user. Then we have this vision-based registration and tracking, which basically analyzes the video feed from the device, from the camera of the mobile device, and tries to detect visual features and track those, like for example AR markers and tags. And then we have this 3D scene manipulation, which basically does sort of conversion between the information gained from these two components into the actual 3D view, so that, for example, the virtual camera in the 3D world can be rotated accordingly with how the device is actually rotated at the same time. So this translates these sensor events into the 3D view. And we utilize this XML3D as the 3D rendering solution in this framework. And we also have a web service interface for providing access to third-party web services, like, for example, points of interest data service, which is very commonly used in augmented reality applications. And all different kinds of content can be fetched from these third-party web services. So then a bit more about this vision-based registration and tracking, because basically that's the heart of every augmented reality application. So in our solution, this is implemented using a JavaScript version of Alvar library, which is originally developed at the National Research Center of Finland, VTT, and they had only a native version which was written in C and C++ code, but it was then translated into JavaScript using this Ngmast tool. And currently this JavaScript implementation is limited to only marker-based tracking, so we can detect fiducial and image markers with this. So fiducial markers are those grids of black and white rectangles that you might have seen, and image markers are a bit more complex, sort of like logo type markers, but very low. Still, the resolution has to be very low. And here's the basic flow of operation, how this vision-based registration and tracking works. So the video frames come in from the camera, and first of all we need to convert each video frame into an XML3D texture, because that's the format that is required for this tracking algorithm to work. So then in the next step, second step, the actual tracking of the registered visual features is done. And the last phase is, well, it's basically just printing the video frame into the web page. So it's something that has to be done, but it's not really that tightly related to this actual tracking process. And then we have a couple of example applications here. So in the left here we have an application that was developed with this framework that displays a 3D model of a house. And the user of the application can view the model of the house either from the outside, or you can also go to the inside of the house and see, for example, here you can see a window and the outside world can be seen through the window. So this type of application would be utilized, for example, in design work. So you can view how the building would actually look like, what you would see through the windows and so on. And then in this another example application, we utilize this vision-based tracking. So in this, there's a piece of paper there on the table where there's a printed AR marker. And then this application basically just renders a 3D, very simple 3D model of an airplane on top of this marker. And then the user can view the airplane from different sides by just looking at it through the application. And this has also an interactive element. When the user taps on the touchscreen on that airplane, it will fly up to the sky, and you can actually follow it by looking into the sky with the device. Then we did some experiments regarding these performance issues and challenges. We had 3 mobile devices that we utilized in these experiments. We had a laptop, which was the most powerful device of this, and then we had a tablet device and a smartphone, and the smartphone had the least processing power of these 3 devices. And then we utilized also 2 different web browsers to see if there's any significant differences between those. So we utilized the, I think, most popular 2, Mozilla Firefox. We used the nightly version, and Google Chrome, which we used the beta version. So we wanted to use the very latest versions of these browsers because we are using the latest technology, and there's huge updates basically on these technologies on the latest versions. So here are the research questions we wanted to answer with these experiments. So first of all, it was regarding this vision-based tracking. So we wanted to know how is the processing time distributed between those 3 steps that I showed earlier when using different mobile device and browser combinations. The second one was that especially with this image-based tracking, so how much does the reference image size affect the performance? And the third was that are there any significant differences in these different implementations of this type of vision-based tracking solutions? So we compared all of our implementation into an open source marker tracking library called JSR Toolkit, which is quite popular in the web context. And then the final question was that how significant is the variation of sensor values when obtained using different web browsers? So we wanted to see is there any difference in the signal that we get from these device sensors. Okay, so here are a couple of charts that basically try to answer the first 3 questions. So here in the left we have processing time for 5x5 visual markers, and then on the right we have processing time measurements for image markers using this our library. And for the first question, basically regarding the different steps in this analysis, so we had colored these steps. First step is blue, second is red, and third is green. So for Chrome, the first step, Chrome has a bit better performance with the first step, which was the image conversion into this suitable format, than Firefox. But then again, Firefox has a bit better performance in the second step, so, which is the actual marker tracking phase. And the third step was basically, it was quite negligible, so there's no real big differences in that. It doesn't really affect the performance. The first and the second step are the most important ones. And for the second research question, how much does the reference image size affect the performance? So from here you can see we have compared 16 by 16 and 64 by 64 reference images. So it's clear that the performance with the 16 by 16 is much better than with the larger reference image. So when the reference image gets larger, the performance drops. And for the third question, when we compare this Alvar and JSR toolkit implementations, so with the Chrome web browser, this JSR toolkit seems to have a bit better performance compared to this Alvar implementation. But then again, with Firefox, you can see that it's the other way around, so the Alvar has better performance than JSR toolkit. So we think this is related to the way that this Alvar library was translated from native code into JavaScript code, so that method somehow produces code that runs more smoothly in Firefox than in Chrome. And there's also a table. You can see actual frame rate readings from detecting. So here's the most simple fiducial 3x3 marker, and here's the most complex image marker 128 by 128. So you can see that we get quite nice FPS, especially on the laptop device with these simple markers. But when we go to these more complex ones, the performance really drops down, and the application becomes basically unusable. And then the fourth question, which was that is there a difference in the signal that we gain from the onboard sensors of the device with different web browsers? So on the left we can see acceleration data from a Chrome web browser, and here is the same thing in Firefox. So you can see that the signal in Chrome is much more noisy than with the Firefox. So this suggests that Firefox employs some sort of filtering mechanism to this acceleration data before it's before the application can get the information. So the Chrome data was much more noisy, and this Firefox data is much more actually. It looks a lot better because the test was conducted so that the user was walking at a steady speed, so you can actually see the steps in this data, but this is much more noisy. Okay, so then the conclusions. So when using this sensor-based tracking, the performance of a mobile phone isn't that much of an issue. More important is the quality of the readings that are obtained from these onboard sensors. And this vision-based tracking, it requires a lot of processing power. So in our tests, we managed to get around 10 FPS on the tablet device with these very simple markers. But then when we utilized the more complex ones, the performance dropped to a level that was no more usable. And this natural feature-based tracking, which basically means that you could use any kind of reference image, even huge ones, so it's not really feasible yet to use on web browser environment because it would be too burdensome for this. And also one important step for improving the performance in web browsers is the parallelization of JavaScript execution. So currently JavaScript code is basically it's single threaded, but there are some things that you can do, like use web workers, for example, to get some parallelization, but it's not very easy to do yet. So, and modern mobile devices have multiple CPU cores already, so this would be a very efficient way to improve the performance. And also, highly optimized computer vision libraries are required for this video feed analysis tasks. Okay, so that's it.
Thank you. Questions, please? Yeah.
You mentioned that normalization significantly improves the performance and the availability of multiple cores is also good news. So can you elaborate more why, and you mentioned also it is challenging. Can you elaborate more why it is challenging?
Well, this is a challenge, especially when programming in a web browser environment. So when you write JavaScript code, you cannot like natively use multiple threads. Like if you write native code, you can use a multi-threaded implementation that utilizes efficiently all the cores that are available. But in JavaScript, the basic function is that JavaScript is single-threaded, so it will utilize only one CPU core. You cannot write a multi-threaded application. But there are some ways of doing some amount of multi-threading, like I said, web workers is one of these, but they are basically just background processes that you launch and they independently do something, and but it's not very fluent way of doing this. So what I mean is that there should be some ways to write JavaScript code that it would be multi-threaded more easily.
What's interesting in the difference in signaling acceleration of the two browsers, but the device was the same at the same time when you did an experiment. It was exactly the same device,
yes.
And just the two browsers were running together.
Yes.
So, did you study the effect on the final applications on the two behaviors?
Yes, well, we sort of did the evaluation based on the user experience that we noticed. So, for example, Chrome, as the sensor values are sort of noisy, for example, the rotation of the device, the rotation information. So, when you view the AR application, you have some objects placed on top of the real world. So they will move by themselves, and then when you turn the device, it will be, you see some jittering with the objects. They don't look like they are like stable. They are constantly moving. So yeah, that's why it seems that Firefox has some sort of filtering that improves this situation.
So is there a way to have access to the source code of such browsers, or an open source browser to study the code in details?
Firefox is an open source browser, yes it is, but the code base is so huge that you really need to be an expert on the project itself to be able to dig down to the source of the problems. So.
Okay.
Nice one. Congratulations. And there is a difference between native apps. All iPhone users have same experience on using native apps. Android users have same experience. There's web browsers. On Android, Chrome web browsers users have different. Firefox have different experience, and on Apple there's a different experiences, so it's make it more complexity. Then, do you have any idea or forecast? Do you have same experiences working on all browsers?
Yeah. So you mean is there differences in the browsers? Yeah. Yes, there are. So, as I said, the future vision is that there will be a sort of unified platform, that every browser will behave the same way. That's the future vision, but nowadays it doesn't yet work that way. So there are differences, and some things work in Firefox that don't work in Chrome, and you basically just learn this when you come up with these problems. You try to implement something, and then you notice that, okay, yeah, this works in Chrome, then let's try it on Firefox. Oh, okay, no, it's not working, and then you have to do it in some other way. So unfortunately, that's the reality today. So the processes are still quite different.
That's the reason why users choose the native apps. Nice work. Congratulations.
Any other question? So thank you. Our next presentation is entitled with the mobile mixed reality based damage level estimation of the plant lead presented by Satish Kumar. He has got a professional and research experience over 15 years and currently working in the department of CSE WIT Rocher, India. His research interests are cloud computing, mobile computing, and related security issues. He has published over 50 in peer-reviewed international journals, international and national conferences. He has been the editorial member and reviewer for international journals and conferences, and he has worked as general chair, program and session chair for many international conferences. He has delivered invited lectures, keynote speak in many conferences and workshops. He is a senior member and member of many international technical societies such as ACM, IEEE, and many others. He is the vice chair for the IEEE Computer Society India and the quality sponsor for ACM, IITR's student chapter. He has very good collaborations with industry, particularly IBM. He has been the recipient of IBM share. Please.
Good morning. Thank you very much. Okay, myself, Satish, from Tirupati, India. Today I am presenting our research results on actually estimation of disease plant leaves, the disease level of plant leaves. Okay, using mobile mixed reality, in augmented, you can say augmented reality techniques, image processing techniques. And the co-authors for this paper are, this is the paper work due to Mr. Sheetala Prasad, my research student, and the co-author is Dr. Ghosh from same institution. The flow will be something like this, where I initially talk about some current research and the introduction, and I'll proceed for what's the proposed work is, what are the experiments and all that. Okay. Yeah. So any time if you are talking about plants, usually they are categorized based on different types of like more than 40 lakhs of species found in the research, and they are all categorized into these 4 types. And excuse me, sir. Take some water. Sorry for that. Yeah, so usually they are categorized into 4 types, and these are categorized based on the shape, area, coverage, like texture, pattern, many types of these things. Okay, so the requirement is now plants and corresponding diseases need to be identified is the first target, and they are because they are really helpful in various applications like forestry, domestic gardening, education and research, and similar things. Okay, but the manual, doing everything manually is a little bit time consuming. So you need to have a mechanism or a solution which is faster and readily available for example, farmer. Okay. So our goal is to first of all identify the species, or the next goal is to identify the disease. Okay, and immediately provide the results to the user. But the question is how fast it is, and whoever is the user, right, and how efficient it is. and particularly this work is focused towards disease identification, not identification exactly, disease level of disease identification. Okay. Yeah. How to recognize a disease, or first of all, you can say plant. So there are various ways, like you can go with leaf, or you can just recognize it with a fruit, or a root, flowers, or base, or branches. Okay, these are all different ways which you can recognize it. But interestingly, about 95% of the research focused on leaf-based detection rather than with the other aspects. Okay, so because of that reason, we are also focused on this part, and though they can support the accuracy, but the leaf itself can be sufficient enough to detect the either plant or the disease. Okay, so already sufficient work has been done towards leaf detection or plant detection, okay, or identification based on various parameters like shape, color, texture, green margin of the coverage of the particular plant or the leaf. Okay, as I said, now I'll be discussing about only leaf thing, not other aspects. Okay, and these are all the different types of techniques used for detection purposes. Okay, yeah, because India is a developing country, and like the available facilities towards the farmers is pretty much low, and they are not that much educated. The farmers are that much educated, and then the currently available facilities are not that easy to access by the farmers. Okay, so that's the reason why we wanted to develop a mechanism which is more easier to detect, more simpler way to detect, and at the same time it is a faster one to detect. Okay, and the current status in India is like partly we have a Kisan call centers, the farmer call centers provided by the government of India. Earlier in 2006, they have deployed some centers, but it was not successful. So they have dropped with that idea. But recently in 2014, again they started doing the same thing with better facilities. But the ultimate idea is to provide everything, every support by virtue of calls, telephonic calls. Okay, but still it's not sufficient because farmers are very poor most of the times. Usually they are illiterates, so they don't try to call the people, they do not have sufficient knowledge to contact the people. Okay, so that's the reason why these techniques, though are available in India, are very much useless. Okay. Yeah, so the focus of this work is like, in other words, the requirement of the farmers is like they should have something on mobile phones, because these days mobile phones are so cheaper, you can buy hardly 2K bucks. Okay, so mobile phones are very much cheaper, and so the farmers can, every farmer more or less, whether they are educated or not, but they are carrying the mobile phones. So using the mobile phones technology in more efficient way to support the farmers is the aim of in fact this work. Categorically it focuses on 2 points. One is provide the results on real-time basis, and second thing is on field, like immediately they get the results and take the decision instead of doing some process somewhere else and getting the results later, and by the time sometimes it may take days, particularly in Indian scenario it takes sometimes days. So in view of these issues, these were issues in fact, but we have tried to focus on these issues to minimize this. Okay, so that's the reason why we wanted to utilize the ubiquitousness of the devices by overcoming the traditional issues, and the idea of anywhere, anytime can be effectively utilized with the help of mobile devices. Yeah. A lot of work is already reported, as I said, particularly related to plant classification. Okay. So one side, these are the products I am talking about. So these are already deployed products based on content-based image retrieval systems. Okay. And the tab was the interface through which, like, you can use any input device like webcam or any other cameras. Okay. And this is the processing unit where the results were processed and the results were produced to the farmers or the customers. Okay, but still this technology is not adapted by the Indian scenario. This is a recent product, suggested by Dr. Kumar and others, and it is available for iPhone users. And again, this is also client-server based model where the details are provided about the plant and the corresponding diseases are identified and produced. Okay. There are a couple of models towards disease identification as well, like this citrus disease is one model proposed by Paidi Party et al. And the focus is to use HS, color model and binary classifications. Again, the concept is more or less based on client server model, where scanning is done here, processing is done on the central server, and results are produced on this server. Okay. This is another model proposed, which is apple leaf disease recognition model. Okay. By G et al. In 2014 recently, and it is again it's a kind of transform or sparse techniques adapted here. And as I said, these are all either tab based or desktop based models, which were not really comfortable to the user, particularly in Indian scenario. Okay. So the one more aspect of this discussion is that, like, these algorithms, whatever that we are using, are complex. So because of that reason, they are taking longer times, and high computation requirements are there, huge memory requirement is there, and of course power is very much consumed. So because these are all computer vision related algorithms, pattern recognition algorithms, and obviously these are all challenges if you talk about the mobile device. And the focus of this work is to provide the results directly on the mobile device, not involving any other third-party devices like tabs or computing power or anything else. So obviously, if you are talking about mobile device, all these must be taken care, and they become a big challenge as far as detection is concerned. So that's how it becomes the objective of this work. Okay, so minimize the complexity, improve the efficiency, resolution should be as much as good possible. Okay, it should be low memory hungry, low power consumption, and as I said, for the farmer point of view, it should be anyone, anywhere, anytime accessible one. Okay. So okay. So many researchers are working towards species identification, but very less research is reported towards plant leaf disease detection. This is the first point. Okay. And so if at all someone is using this one, then the problem is they are using third-party servers, and third-party servers most of the times provide very late results, or they require huge bandwidth requirements. Probably such bandwidth requirements are not really supported by the network providers or the corresponding small-scale devices. Okay, so and running such high-cost algorithms, ANN, SVM kind of algorithms really require huge computation power, memory requirement, whatever the statements I mentioned earlier. Okay, so that's the reason why the mixed reality-based automated plant disease detection has become really important challenge and an application-based one for the farmer perspective is concerned, and provide a damage level estimation so that farmer takes the immediate steps towards the recovery issues. And obviously, using simple mobile device is a easy mechanism. So, with this introduction, let me talk about the proposed work, how we have modeled this such that the complexity issues, other issues, memory issue, power consumption issue, okay, these challenges were addressed. Okay. So, the idea is the mobile device, whatever I have, just I'll keep it on a leaf, okay, then it should immediately process that leaf and identify the specific disease part and augment it on saying that this much percentage of disease level is there in your device, leaf, so please take the necessary actions. So such kind of immediate response, if it can give, obviously that is the best solution. Okay. And for that, we have to minimize the complexity, save the energy. Those aspects need to be, of course, addressed here. So in view of that, we have tried to make several steps here in processing, because we are doing every process on mobile device itself. We are not using any server for this purpose. So the power consumption should be less, and in view of that, we have tried to optimize the algorithms in such a way that the results are produced in a faster manner. Okay. So mobile device scans the leaf and processes it for the damage detection and estimation through various steps like leaf acquisition, pre-processing, segmentation, and finally the damage level estimation. Okay, all the computations are carried out on the mobile device alone, as I said earlier. So let me talk about the various steps, how leaf acquisition is done and how it minimizes the energy consumption. Okay, how pre-processing is done. So the various steps now I will discuss in this model. So leaf segmentation is still lying as a live challenge, of course, everybody knows this, and natural leaf in a natural complex background, like if you consider the first image, like the background is almost like this is the leaf, I have to recognize, but it's having similar background, so segmentation becomes a very big challenge. Okay, sometimes I image like this, and if you have a white background or a constant background, then it's very easy for doing that. Okay, so our work focus, of course, with the initial idea on this one. Okay, but we are also working currently to use this these types of leaves where even segmentation can be done on a leaf. Okay, so that's why I use the word semi-segmented leaf, where it is captured in a uniform, stable background considered for experiments. Okay, so that there is no burden on isolating the leaf. So this is one, you can say, assumption or disadvantage of this model, where farmer has to carry a specific constant background. Okay, and if that behind the leaf, then capture the image. Then only this model really works well. Okay. But really, that saves a lot of energy of the system. Okay, the mobile device. So that's the reason why we have just exempted that processing here, because mobile device cannot accommodate such segmentation job on a mobile device. Okay, and while acquiring the leaf, the preliminary operations are done, like it is assumed that it is a rinsed leaf before it is used, so that any dust, sand, mud, anything is there on that, which lead to misinterpretations of the results. So those kinds of cleanings are done on the leaf before it is used. So the disease stain of leaf is basically absence of green color, and this is the second assumption we have made in such a way that it uses only green color, not the other color based leaves. Okay, and this is the second direction towards which we are working currently. But in the current state, we are using green as the basic color, which is segregated here. And but of course, but the advantage of this model is that it doesn't care in which direction or in which orientation the mobile is kept and captures the image. It automatically takes care of the orientation of the leaf. Yeah. So RGB color space is used here. Whenever frame is selected, particular frame is selected through see-through mechanism. Okay. And noise removal, color transformation approaches are used here on this particular image. So three-dimensional space. Let me represent it as I RGB in 3 dimensions with XY coordinates. Okay. So frame image selection is done like either scanning or you can say capturing the image directly through your device over the plant leaf. So scanning in the sense here is not capturing. It's not capturing, but it's just moving your mobile onto the leaf. Okay. So there is no need to capture the image. Just move it automatically. It takes the frames, corresponding frames, suitable frames, I should say, from the list of available frames. So from the set of frames, it selects particular set of images, and best images taken for estimation of the particular image disease level. Okay. Yeah. So these are of course already discussed. Yeah. The point is here we are not storing anything on the device. Okay. That's the reason why even storage is not a big issue. It's not a video that is stored. It's a single image that is stored, which is selected while scanned through the. So for that, the idea is simple entropy is used because computation cost is very less, and entropy, using entropy, a particular images among the n number of images in a particular frame per second. Okay, a group of frames per second. Selected images are chosen, and first initially it's converted into grayscale to select that particular image. So this is a approach we have used where t-1 frame and each frame entropy is estimated, and if the threshold is equals to plus or minus t, it's equals to t, then it is understood that there is no difference between the previous framed image and the current framed image. So we have discarded that particular image. We are not using it for the processing. Instead, if there is sufficient difference between those two images, then that particular image only selected. So instead of, if you are talking about 30 frames per second, so not all 30 frames are chosen, 30 images are chosen, but only selected images are chosen, hardly 2 or 3. I'll tell you how many it is in the coming slides, but 2 or 3 particular images are chosen. On that 2 or 3 images, the corresponding processing is done, and it is after pre-processing, a relation is made whether it is non-diseased or diseased, and based on that, damage level is calculated and result is augmented on the mobile device itself. So this is what exactly mentioned here. Instead of capturing a series of images and process them, the frame image selection process is carried out at every mu interval of time to reduce the further computation cost. So suppose there are 2 successive frames, t-1 and t, then their entropies are so and so, it should be vice versa. And if the difference between them is tolerable range, then particular frame is, those frames are similar, then they must be discarded to reduce the computation, otherwise they are sent for pre-processing. Okay. This is an example how it is selected, like if 30 frames are there, hardly first one and 15th one are selected and all others are discarded for processing purpose. Assuming that FPS is 30 here. And for this purpose we have used time series entropy graph for analysis purpose, and based on that particular points are selected and out of every one. When sufficient entropy difference is there, then only they are considered for computation. As I said, the requirement is to reduce the computation cost and power cost. Yeah. The next step is pre-processing, and in the pre-processing, it is converted into RGB color space is converted into lab space. This is the second important decision we have made in our implementations, and the lab space chosen because it is device independent color space transform. Okay, and that way we can achieve the accuracy of the results. And it's more, it comprises all color sensations that a human eye experiences. So these are the reasons why we have chosen lab color space for this model. Of course, computation cost is also relatively less compared to RGB space. Noise removal is done by average filtering. Normalization is done with here on this average filtered image on lab color space, leading to X-dash, Y-dash coordinates, and then unsupervised segmentation is done using K-means algorithm, so that there are three images produced: a background image, a deceased image, and non-deceased image. So three categories are classified here. So three categories are classified here, and based on these images, these three images, the Bayesian estimation level. Now we want only deceased one, and using the deceased one, we will try to estimate what is the disease level in this. Okay. So for estimation purposes, it is converted into a in order to have the binary operations to further reduce the computational efforts. It is converted into black and white image. Okay, and that black and white image is applied with open and closed transformations. Yeah. And then in order to estimate the disease level, now this is a diseased image. Okay, in order to estimate the disease level, for that purpose, this is the total area of the leaf, which is the non-diseased one, and this is the diseased one, where the percentage of area is calculated on this black and white image, so that we get the diseased image percentage. And it is converted into angular transform, and damage levels are metered at 10-point scale between 0 and 9 based on percentage. Okay, so now these are the damage levels. Okay, and this is the percentage of disease on the particular leaf, and based on that, the predictions are made how serious it is. Normal leaf, we assume that is a dry leaf, maybe a diseased leaf, of course, but it's not that serious impact. But from here onwards, the seriousness commences, and at 95% and 100% levels, it goes to even, you can say, dead, leaf is dead. So above this 50%, it becomes critical, and even farmer cannot go back at any point of time. So this is almost like no use kind of implementation. Yeah. For this purpose, we have prepared, because unfortunately we don't have disease leaves available. A dataset is not available, so we have to prepare our own disease data set, and we are in a collaboration with Forest Research Institute in India, where pathologists are available. We were taking the help of those people, and we were trying to analyze these leaves with the help of them. And totally 297 leaf images are captured, and as I said, no publicly available data. Algorithm proposed is resolution tolerant, so whatever the resolution of mobile device is, the algorithm will work fine with that resolution. Okay, hardware and software requirements related to experiments. We have considered Micromax mobile device, which is very cheapest one in India. Hardly comes in $4,000. Okay, so with that we have tried. Its processing capacity is 1 gigabyte, 512 MB, and 2 megapixel camera. And we have started with that basic phone, so that farmer can afford such a basic phone for the usage. And it is assumed that it is an Android-based device. So it is, of course, right? And for the experimental evaluations and calculations, we have used this software. Okay, now these are all already discussed, but just to summarize in other words, in Indian scenario, as I said, they are food farmers, unaware of technologies and economic problems, and they cannot afford. And damage level is converted into, in lieu of these issues, we have taken the results into a simpler form where it should be produced as a simple pie chart or just a number, a simple number. It should be diagrammatic as well as a number, numeric one, so that they take the decisions faster. Okay. So for that conversion into pie chart, further steps are taken care. This is a result in which it appears like number, numeric result is shown at the same time pie chart is shown, so that the user will easily understand what is the disease level is. In fact, the previous diagram, blue color indicates the percentage of disease level it is. Okay. And computation cost is also estimated, and this red line indicates the computation cost. And with the resolution and the image quality, even you go with 8MP or better than that. Okay. The computation cost is not too high, it's just hardly a linear one. So really it's applicable to any device that you are using. Okay, so these are the different resolutions we have considered, and it is understood that if you use VGA approach, then resolution, then it's hardly 0.0189, nearly 0.02 seconds of time it is consuming. Really, this is a great number, and it's an immediate, real-time output for the. Yeah, I'm done. Okay, just to ensure that lab color space is meaningful for this user. Later we have done several experiments towards that, comparing 3 types of color spaces, and it is understood that this is giving accurate results compared to other color space models. Right. I can skip all these slides. Like these are all application scenarios where you can really talk it. So let me conclude the talk. As I said, this model is a mobile see-through system, and it's novel entropy-based framework selection and robust unsupervised lab color space model, which is device-independent result, which produces device-independent results, and auto-grading interactive system, so that only pie chart-based results are provided to the farmer, so that immediately they take the decisions. Okay, algorithms are very much optimized in such a way that they are producing the results in very faster way. And as I said later, I mean we already taken up some research towards these directions, and taking the complex background instead of white background. Okay, and here of course we already implemented distinguished disease model of a leaf from simple dryness model. Yeah, actually this is the next biggest challenge in this research, because currently disease identification has become a big challenge, so we are focused only on that part. Now we are focusing on the second direction, where you cannot differentiate disease and dry leaf. So that is the next challenge for us. So we have taken up that in the coming work. So that's all from my side. Thank you very much.
Thank you very much. Any questions, please?
Yes, please.
Why is it so important to do this computation locally, not globally?
Computation is low.
I think to do all the computation of segmentation, etc., why is it so important to do it on the mobile device, not just take a few pictures, send them to a remote server that will do this complex computation?
Yeah, that's a good point. That's a good point. I already mentioned in the beginning that, like, see, you can, if you have to send it to a server, then you should have a good bandwidth as well, right?
Okay.
Okay. As I said, it's an Indian scenario we are talking about, and in Indian scenario, hardly you find Wi-Fi based networks for the farmers, right? They have to use either 3G or any mobile data networks, and the communication cost is extremely high compared to and mobile battery drastically goes down if you go with the mobile data networks.
So even sending a few pictures to the remote server is difficult in this kind of
as I said, it's
devices.
low-cost devices we are focusing on, which are really available for the farmers. Okay, so in such low-cost devices, typically one challenge is power, and computation cost is the second challenge. And of course, the third challenge is communication, where they cannot afford for that communication cost.
Thank you. Thank you very much. I think we have a short time to present the other two presentations. The first one is entitled with AVIS, an adaptive video simulation framework for scalable video, presented by Ahmed Zahan. He is an assistant professor at the Electronic and Electrical Communication Department, Faculty of Engineering, Cairo University. He previously worked as postdoctoral research with the MISL group at the Computer Science Department, University College of Cork, Ireland. He obtained his PhD at the Department of Electrical and Computer Engineering, University of Toronto in 2007. He received his BSc and MSc in Electrical Engineering from the Faculty of Engineering, Cairo University in 2000 and 2002, respectively. His research interests span to...
We don't have a lot of time.
Shall we start?
Okay, let's start. Thank you for the introduction. So, the title of my presentation today is AVIS. It's a new adaptive video simulation tool for streaming scalable video in network simulator tool. So the outline of my presentation is basically 4 main points. Start with the motivation and some background, and then I'll present the architecture and the implementation of this simulation tool, followed by a couple of use cases that we just used to illustrate the distinct features of the newly developed tool, and finally I'll conclude my presentation. Starting with the motivation, everyone know from the keynote speech today that video streaming is getting more pervasive, taking over around 2/3 of the data traffic, either in the wired domain or in wireless domains. And typically our network features significant heterogeneity in terms of device heterogeneity. We find many devices with different capabilities and different screen sizes, and also we feature resource heterogeneity because we are using different networks, either we're talking about Wi-Fi or talking about 3G and 4G and whatever 4G plus and 5G, as we have seen in the keynote today. So it's an important requirement is to deliver video at different qualities to different users in this heterogeneous setting. And scalable video coding techniques has recently evolved, standardized into 2007, to support adaptive streaming with efficient storage and transmission characteristics. So talking about scalable video coding, 3 main scalability dimensions are defined, starting with spatial scalability, which means that you can transmit your video at different resolutions and now reaching high definition and ultra high definition videos. And also another scalability dimension is temporal, which means that you can transmit your content at different frame rate. You are not sticking with a single frame rate. And finally, the third dimension is quality, which means that you can encode your video so that every picture is could have different quality level. So basically, in these 3 dimensions, based on these 3 dimensions, 2 dimensions probably would be used at least for encoding video for such heterogeneous settings that we have talked about. And we believe that scalable video coding is not adopted because there are a few tools that exist to evaluate the performance of video streaming, or either we're talking about streaming algorithms or new encoding features. So this motivates us to develop our simulation tool. But before talking about simulation tool, I'd like to present just the general performance evaluation framework for different video streaming independent of the encoding. Basically, you usually start with your raw video, which is typically a YUV file.
you do some kind of pre-processing on this video. This pre-processing includes encoding, video encoding, and extracting some the information about the encoded video. And then you go to the second stage, which is the transport, which could be done in real test beds or or through simulations. And finally, after the transmission of the video, you may need to do some kind of post-processing to evaluate the performance of the streaming. This kind of post-processing could include analyzing some of the traces that you collected during your evaluation process. Also, you may need to do some kind of video decoding to assess the quality of the received video, either through subjective or objective kind of testing. To do all this, few open source tools exist for scalable video coding. The most notable one is GSVM, which is kind of the Swiss knife for anyone who would like to work in scalable video coding domain. GSVM provides a set of tools including an encoder and some kind of bit stream extractor that provide information about the encoded video. On the post-processing side, it provides a decoder. It provides also a tool for calculating big signal-to-noise ratio, which is one of the main KPIs in the area of video streaming. And also there's another tool that we find very useful, which is OpenSVC decoder, which is kind of an alternative for the GSVM decoder because it has a lot of issues in its performance. So these kind of tools are considered like common tools for existing frameworks that are used to evaluate the streaming performance of scalable video. In the literature, we would like to highlight two main tools. The first tool is, or I would call evaluation framework. The first one is called SVEF, the Scalable Video Evaluation Framework, which target the delivery of H.264/SVC video in real networks. So it basically implements a server that encapsulates 264 SVC in a simplified RTB structure. And also it implements a client that reassembles the transmitted video, and it also develops some pre-processing and post-processing tools that we will talk about them in later slides. The second tool that also attracting our attention is MyEval SVC, which is basically enables SVC streaming in Network Simulator 2. And this is basically what this tool is doing, is that it developed tools to create traces that are compatible with NS2 traffic generator. It also replicate the SVEF encapsulation in NS2 by developing a special UDP kind of implementation in NS2. And also it analyzes it traces the packet transmission in NS2, and these traces are used to identify and regenerate the received video after the simulation. But probably in most of the cases, it's MyEval SVC inherits a lot of tools from SVEF. So it's considered a kind of extension. It extended SVEF to enable video streaming and network simulation too. So none of these tools support controlled adaptive streaming, nor support generic encoding. And we will talk about these features in detail when we are talking about what we have done in our tool. Going further, we'll start talking about our tool, AVIS, and this picture highlights the architecture. So basically, we have some tools that we developed for the pre-processing stage, and also we have some tools that we have developed for the post-processing stage, but also the core of the work is done in NS2 by implementing AVIS transmitter and AVIS receiver, and also producing some kind of modified version of the UDP that's implemented by MyEval SVC. So we will talk in details about every one of these components and elaborate what we have done. So in terms of supporting adaptive streaming for scalable video, our tool, let's say that the main difference between our tool and previous tools, that previous tools, either we are talking about SBF or MyVal SBC, none of them do any kind of control on the transmitted packets. So you have some trays with the packets, and you bump all the packets that you have in these trays without any control. So we have added this feature here. So assuming that the user is interested in a selected quality, so we implemented some kind of filtration. Only transmit the set of packets that are required to decode this quality. And to elaborate more on this, this is like a snapshot of the output of bitstream extractor tool in GSVM. So basically, this snapshot just gives you an information about the video encoding. So here you have some layer number 0 up to 15. You have the resolution of each layer, the frame rate of each layer, the frame rate of each layer here, and also you have the bit rate that's required to stream this layer, and finally you have some kind of information that reflects the dependency between different layers. In this term, I mean that if you are interested in streaming a specific quality, let's say you are interested in streaming the video at this resolution, at this frame rate, and so on. So basically, you don't need to transmit all the packets that you will find in the trace, but you only need to transmit the dependent parts of the packets. And for this case, that would represent transmitting 001, 010, and 000. And basically, every element of this tube corresponds to a specific dimension of the scalabilities that we have mentioned. So the first element here represents to the video resolution, the spatial scalability. The second element here corresponds to the temporal scalability, and the last term corresponds to the quality scalability dimension. So basically, once you choose a specific quality layer, whatever this quality is, we implement some kind of filtration for the packets to be transmitted to satisfy this quality. The second feature that we embedded in our tool is adaptive transmission rate. So as we have seen, every layer would have a specific nominal bit rate that's required to transmit this video at this specification. In our tool, we enable streaming this video at different rates. So imagine that you are transmitting it at a faster pace or at a slower pace. So you are still transmitting this video at this quality, but you are transmitting it faster or slower, and we'll see why this could be a useful feature. So just to elaborate, if we selected a specific quality, and this quality had a nominal streaming bit rate of 250 kilobit per second, but your available bandwidth could be, say, 500 kilobit per second, which is kind of double the rate required for streaming this video. So this is we can adjust the streaming speed by speeding the rate at which the frames are transmitted from our devices. If we have assuming that we have the video stored on our server. So we define this download ratio, which is 2 in this case, and we use this download ratio to scale the interframe duration between the transmitted frames. I hope I'm not going too fast, but I know we are running out of time, and I don't want to stand between you and the lunch. But this feature, we found it very useful for specific use cases, such as heterogeneous networks, in which you move between networks such as Wi-Fi and 3G, and we will get this in detail in the first use case in our result part. The second case is in some algorithms that we have seen in the literature, you may need to probe the network for bandwidth. So you have a selected quality, but sometimes you may need to just say, let's put more traffic and see what the network will do with this additional traffic in the system. Some proposals are based on this idea and react to whatever the outcome of network probing. So in this case, this can be done by just adjusting the download download ratio in your algorithm if you are using our tool. The second distinct feature in ABIS is generic encoding support. So basically, existing implementation, which is mainly based on SVF developed tool, fails to properly differentiate between control data and the frame data for generic encoding. They have, so basically it fails, we found it fails because the differentiation between control data and control and data frames within the trace are based on the frame size. And this is sometimes works fine, but in other encoding it fails if a data slice becomes as small as the control packets. And this is very common as you get a larger group of pictures within your encoded video. So we developed a new scheme that identifies the dependency correctly. I'm not going into the details of this scheme, but interested readers can find it in the paper. And during the simulation, also on receiving the video, there's some kind of dependency between frames. So there exist I frames and B frames and D frames, and some of them depend on other. Some of the frames depend on other frames. So existing tools developed by SVF only implements some kind of online dependency, identification for signal to noise ratio, temporal signal to noise ratio scalability. So it's not available for generic kind of encoding, which is one of the most important that they are missing is spatial scalability. And we know spatial scalability corresponds to different resolutions between different devices with different characteristics. So it's a very important feature if you need to test real or what you expect to be implemented in the real life. In terms of the implementation in NS2, ABIS TX inherits the standard traffic generator and add additional functions to it. These functions, including the null unit filtering, the filtering features that we have mentioned, and also it implements adaptive download rate, which is related to the download ratio that we have mentioned, and it also adds some functionality such as pause and replay, which are not supported by the standard traffic generator in NS2. Additionally, we support setting the parameter from pause. We provide the means to support setting the parameters such as the quality and the download ratio from pause, the FECL, and C++ interfaces in NS2. In terms of the receiver implementation, it's implemented in two stages. The first stage is the receiver itself, which basically receives packets and compiles the frames from packets and compiles a group of pictures from as a decoding unit from the frames and delivers them to the second stage, which the second stage basically simulates the application buffer and also deliver packets at the proper rate for display. In addition, we implemented some. It's an important feature to collect traces during your simulation to enable you to do some kind of performance evaluation. Among the parameters that we collect, we collect some kind of backdropping rate, frame loss rate, the quality of the received frame, the bit rate, average bit rate that we are receiving the stream at, and all these parameters are very useful for any adaptive algorithms. They are used either as like an input for many adaptive streaming algorithms. Moving to our use cases, our first use case is close adaptive streaming in heterogeneous networks. Our basic scenario is that the user, a mobile user, is moving in the system and he is traversing different networks such as Wi-Fi, and maybe sometimes doesn't have dual coverage, only he has to deal with the cellular system. And we all know that the cost of the service in Wi-Fi is definitely much cheaper than the corresponding cost in the cellular network. So this mobile device is interested in performing some kind of cost-adaptive streaming. And the key idea for cost-adaptive cost reduction here is to buffer when you are in the cheap network and use the data or what you have buffered when you move to the expensive network. The highlight for the algorithm. In the cheap network, you stream at a selected quality at a high data rate to secure certain amount in your buffer, and this certain amount is determined by a high buffer threshold. And when you move to the expensive network, you need to stream at low data rate to save money, but you should never go below a low quality service threshold to avoid the video interruption. You have to adjust if you approach these thresholds. This figure shows a scenario in which the user stays for 20 seconds in the cheap network and then moves to the expensive network for probably 180 seconds and then move for the rest of the simulation to the cheap network again. And this figure shows us the buffer time versus the time in second. And as you see here, the application keeps buffering the media when you are in the cheap network, and instead, when you move to the expensive network, you start to deplete what you have in your buffer. When you reach the lowest threshold, you have to maintain it at this level and don't go below it. You still have to stream at the nominal streaming rate for the selected quality. And then when you move again to the cheap network, you can see here the dynamics of the buffer, and also you can see the effect of the dynamics of the buffer on the perceived quality of the video. So whatever algorithms that buffers more is reflected here in terms of higher perceived quality. So basically this is just to highlight the operation in the first use case. The second use case, considering shared bandwidth, and in this scenario, assume that we have two nodes that will stream videos to another two nodes, and these two sessions will share a bottleneck link. The bottleneck link bandwidth is set to the maximum streaming rate for the tested video. The first session starts at the beginning of the simulation. The second session starts at the quarter of the video duration. So if the video is 10 seconds, the second session starts at 2.5 seconds. We have tested multiple videos, including Big Bunny, Coast Guard, Foreman, and Barris, which are widely used in our community for performance evaluation of video. This table shows the encoding structure showing the dependency and the corresponding frame rate, and corresponding bit rate in kilobit per second for the tested video. We tested 3 different strategies. The first strategy is a non-adaptive strategy in which the streaming will be performed always at the maximum rate and the maximum quality. The second strategy, and in this case, you will only select all the videos will be streamed at these data rates. The second strategy is high bit rate. So we assume that we have some kind of continuous bandwidth monitoring, and you have an estimate for your bandwidth R. So you select the quality that just fit below this bandwidth. So basically here, this algorithm, it's not clear here, but there are some in circulation here. For the second strategy. For the third strategy, again, we fit our streaming within the estimated bandwidth, but we choose to stream at the maximum frame rate just below this, within this bandwidth, and this would correspond in this case to this set of rates. And we implemented these algorithms in C++, and integrated with NS2. This figure shows the packet loss rate versus time, and this is showing for non-adaptive cases the losses can achieve up to 50% of the packets are lost. For the second video, for the first video it's a little bit less. And these losses affect the consistency of the stream, the quality. As you can see here, the frames will have a lot of quality shifts during the streaming, which is kind of one of the most annoying problems in video streaming, while adaptive schemes would maintain a consistent quality based on each one based on its selected quality. And finally, this figure shows us the peak to signal noise ratio for the 4 tested videos. compared to the maximum possible, which is basically the output of the encoding process. And for all the tested scenarios, we find that the last strategy, which is based on that combines the estimated bandwidth with the maximum frame rate to achieve the highest quality, except for one case. I will not talk a lot about this case, but anyone interested, I can explain why we have this behavior here. And this is basically shows, as our second use case also shows the flexibility that we have in implementing different streaming algorithms. And in conclusion, scalable video coding supports adaptive streaming in a bandwidth and storage friendly manner. ABIS provide a generic and flexible framework for simulating adaptive SVC-based streaming algorithms. And finally, as future work, extending ABIS to support other encodings such as state-of-the-art 265, and porting ABIS to other tools such as NS2 and maybe real implementation for server in the client is.
Thank you very much for such an interesting presentation, and we have one spot. Any questions, please?
Thank you.
Okay, thank you. And our final presentation is augmented reality with applications with mobile agents in the Internet of Things, and again with our friend Arthur.
Okay, thank you. I'll try to make this really quick so we can get some lunch. The idea of this paper was presenting a prototype system where basically augmented reality was used for visualizing IoT environment. And these mobile agents are utilizing this in this Internet of Things system. These are basically computer programs that can move from one device to another and sort of continue their processing in a new device. So first, a little motivation why mobile agents in IoT or AR. Well, first of all, this augmented reality is sort of provides a natural user interface for this IoT smart environment, so that you can render the, for example, readings from some sensor device on the actual location where the sensor device is located. So, for example, in some industrial environment, you can monitor the equipment in a natural way. These mobile agents, they enable injecting these application-specific computations into the system, which allows creating agent-based services, and these agents are reusable in different applications and services, and they are also platform and programming language independent, because you can write these computations in several different programming languages. And these agents also adapt to the fluctuating IoT system environment. And these mobile agents are transferring code between augmented reality application and the system devices. So the augmented reality application itself can actually inject some computation into an IoT system. And this application-specific data processing and UI code for different platforms is also enabled. And these mobile agents live in this system without any specific couplings with AR applications, so it's a loosely coupled system. And this system is also enables integrating IoT with the web. So based on a resource-oriented architecture, where basically everything is a resource. So these resources include, for example, the system devices and their physical components, such as the sensors and the actuators. Also, these mobile agents that live in this IoT system are considered as resources. And in this augmented reality case, points of interest entities are also system resources. And this resource-oriented approach basically brings a unified and standardized communication for resource access and control, so you can use the standard HTTP methods for accessing and modifying and deleting the resources. And it also facilitates seamless information retrieval and control for both physical and virtual objects. We utilize this same AR framework as I've already presented in the first presentation, so I'll just skip this slide. It's already presented. So here is the prototype IoT system architecture. It has basically 6 different components. Here's the augmented reality application, and the points of interest database, and we have a web proxy component that basically translates the HTTP traffic from the AR application into this IoT or wireless sensor network, because they use different protocols. And we have a distributed resource directory for resource lookup, and then we can have different kinds of repository resources. So this architecture is based on the IETF core workgroups framework, and this wireless sensor network is based on 8-bit microcontroller nodes. This system components, so the resource directory, it stores the system resource descriptions such as name, URI, current address, and so on. So there's different resources can be looked up from this resource directory, and then this proxy component, it translates the protocols of these different networks. So it translates from HTTP to co-op protocol and back. And then these different repositories can host any data basically. So in this example, we use this points of interest database to host these geographic entities. And then we made a proof of concept application, which was a mobile AR application running in a web browser, a tablet device. And the function of this application is quite relevant to many researchers because it shows the freshness of coffee in a coffee maker. And so here's the basic flow of operation, how it works. So first it takes the augmented reality tag from the video feed, so there's an augmented reality tag attached to the coffee maker. And then it retrieves a point of interest description that is related to this augmented reality tag. And this point of interest description basically describes this device, and tells where it's located and so on. And it also links to the mobile agent that is sort of living in this IoT device. So from this link, the augmented reality application can then fetch the current status of the mobile agent and display on this augmented reality view. So you can see there's the coffee machine on 15 minutes, so you can show the state of the mobile agent. And so the coffee maker was connected to a wireless sensor network node which monitors its power consumption, and there was this AR tag attached, and the point description which was linked to a mobile agent. And this mobile agent then calculates the time since the last state change of the coffee maker. So we had some threshold values for the power consumption to determine when the machine is on and when it's off. And here's some examples of this agent composition structure and the POI data structure that we utilized. Okay, so in conclusions, so augmented reality is a natural way of visualizing information from these different IoT devices in smart environments. And then our web browser provides a uniform application development platform for these AR applications. And IoT systems and applications become web-enabled with the resource-oriented architectural approach where everything is considered a resource. And these mobile agents, they enable injecting dynamic application-specific data processing and information visualization in the system. And there's this presented prototype application for showing the freshness of the coffee. It was actually very straightforward to implement it with an IoT system architecture. It required only quite a few lines of code. Okay, that's it.
Thank you. Any questions, please?
Probably I missed some detail during the presentation. In practice, where does the mobile agent work? So you move the agent to the machine, or so to control in any way the machine.
Yeah. Actually, I'm not the first author of the paper. Then is the person to answer this question, but to my understanding, mobile agent, they can have several use cases. But in our case, the mobile agent was not moving around; it was staying at the coffee maker. So it was basically providing a service which tells how fresh the coffee is.
Okay.
Yeah, but his question is valid because mobile agents moves from one place to another, and so there should be a platform that will host these agents. And maybe in the IoT and the Internet of Things, the most interesting thing is to have the portability or how to accommodate or host these mobile agents in the things in the Internet. So maybe this is a future future access.
Yes, because another perspective would be that there is a mobile agent that in some sense is related to the machine, so and of course it's the bridge between the rest of the world to the machine, so it can be moved to services that need to communicate to the machine, something like this. That was the rationale behind my question, to understand exactly which way you thought about the use of the mobile agent with respect to the rest of the world. Okay.
Other questions?
Thank you.
Other questions? Thank you very much.
Okay.
And we conclude our session for today.
Thank you, everyone, for your this time, because we were running out of time, but now it's, the lunch will be served downstairs. Next we have a keynote here, the second keynote, and after the keynote we have our second session, which is B2. So I asked Shotaro and I asked Elena, but I'm still missing Andreas and Peter Matthew. So I don't know if they are here. So after the keynote, in the break, just approach me, and your session chair will be Arthur, yeah? Great, thank you very much, and please join us in the dinner, yeah? Sorry, the lunch. Thank you very much.
مرة ثانية عشان نجي كده كان يكون جاي
Is it possible to leave the bags here?
Since you did not agree to serve as session chair, no. That's all right.
Oh, okay.
I'll be looking to the room, so I close the room.
Okay, fine. Thank you.
I close the room on you if you stay here.
No, sorry, it's going on site, so it's papers, sorry.
I'm just kidding.
Okay, thank you. I have to prepare myself.
Road to lunch, don't be late. Don't be late. You were late for the session.
No, I was here.
No, but you were probably the last one.
No, in that sense I mean.
Is it okay, the pictures?
Yes, thank you very much. Thank you very much. Next.
Sulaiman, come on, lunch.
I'll be there with you.
I need to close the room, so I have to close the room, yes?
Again?
Yeah, I have to close the room.
One of the captured. Neither, do you have the card?
The card is not with me, so I could open from inside. But if it's not, I don't have a card. I take it from
You need to take a card. So, yeah. What? I have. Give me a minute, I just stop over you to the street. Please, sir. Okay, we should go live in about 30 seconds. We should go live.
And it will be the same link, yeah?
Same link. Because Manar told me downstairs, better put it online live
يعني جاي من الأردن
now.
من يا جامعة؟
من الجامعة الأردنية.
أنا حجي I will be in Jordan in October for the Med Dialogue Conference, and it's about really networking for the Horizon 2020. I'm looking to build a consortium, so please do join. And today, if you have any ideas, let's start now. Better early than.
The point is the front one, yeah.
Right, let's try it.
Try it.
Okay.
Right?
And you click?
No, click, you have to click through there, just on the arrow or the tab, yeah?
Very good.
Great.
What? Nobody told me that.
Send the link to anyone who wishes to want to just ask them to search for Ngmast 2014.
Well, we can put it in LinkedIn.
Yeah, you can.
So, what would be the link?
For Ngmast 2014.
I didn't connect to the network. You have a password? I haven't read
Because and the presentation was on the last day.
It gave me
I will not try it. Actually, because I look my everything. After I get information on the problem, what I did change.
Yes, he's holding a gun. It's too much hassle.
Where are you now?
Where am I?
Yeah.
Really?
I know the last time I met you was the cock. You were
No, it doesn't matter. He said that it will be live, and I didn't know about that. I thought it would be a good idea to put it on our discussion board. It will be recorded.
It's YouTube Live.
I don't know. At least in terms of the ranking that you
Hey, it's later on. Let's do that. Let's press it around. If I'm good, then I will publish it.
should have not told you. And then you will be more relaxed.
see where they are.
And then after that, tell you that.
I'm not told about you.
probably to have my contacts where we keep in touch. You have, if you can Google, probably you'll also find my email.
Yeah. We'll be posting something on Twitter. We have Twitter feed as well. So we'll be.
IT supervision LinkedIn, we are usually 1,100 people, a lot of them in senior positions and also lots of security.
You'll be happy to join. You can send us the links so you can resolve it.
I did send it to Dr. Hi, and you join and then you can publish it there. It's better than I publish it, like you publish it.
Tomorrow's sessions are mine.
We are happy to help with the simulations.
I had Arabic subgroup for the Arabic project, I have another subgroup for economic project, another project in general, I will have another subgroup. So yeah, it's a very good community in it, and the last year I have let them do what they like. But the subgroups, I'm going to talk to them much to do and rather than post what they like.
If you follow the road, because we talk about the responsibility for people to do for stuff rather than being centralized.
Oh, I will die if I centralize it.
Yeah, that's what I'm saying. Yeah, more before style of work.
Yeah, but finding the people who work to actually do the job. That actually no one else. So I was talking to if you categorize certain categories and summarize in the report, publish it and publish it for them. Oh yes, students, young people who would like to do something to show themselves. So they will do it.
Yeah, I haven't lately.
More knowledge transfer. But now I'm giving myself towards having students more as industrial people rather than I am
chatting with my husband.
associated with a positive research, but I'm forced to study power. It's all virtual environment.
That's great, yeah.
So yeah, I mentor lots of students, lots of research, show them what they need to do.
I do get it.
I have one Moroccan student who studied in France, university in France and university in Italy. Which language I'm going to examine you is English. Otherwise I can't. But yes, I'm having the end of the year one.
He's just started about 8 months now.
Once you do a lot of management, don't say, or don't strong enough at first, you can't continue research properly.
Even the family life is really quite long. You have to sit on your desk.
Yeah, but for research, you need really to stay put and not researchers, that's why
It's research you need to take office time and family time. So there will be no family time. It's management work. You still have, you can do the office work.
Yeah, it's very difficult to combine networking, management, research, and life.
He's creating distance learning materials how to teach computer.
That's why the head of department always says creativity. I got somehow.
Having some connections, but I know I've been here for 5 years. So I know how to some kind of social life.
Yeah, Portsmouth is very small city. I have a lot of friends there. You just walk with them. I like London. Yeah. it is nice to be transported. Because in London, I have a lot of cultural family, but to get to them after work, you can't be bothered. Tired to drive half an hour. Distances that usually you should have less than 15 minutes can't take half an hour. So that's why you end up not part of the research project. Very technical. Or online advice.
Yeah, of course. I took my family to last year in Manchester. Actually, what told us was but it is smaller than we expected on the photos on the website. We thought that was something like very colorful. Yes. I know. It's fine, don't worry. Yes,
You can take it off of there.
It doesn't matter.
In 2012. 2012 December was my long story. They split one position into two.
Very well known last year I think done
Here has changed. I think I'm in the right place. So more of academics here on the list. So the last 1.5 years I have done much of research on market publishing only. I have to pull up my source now. Income source.
Okay, good afternoon. To continue with our program, I hope that you had good lunch. This restaurant is the same restaurant where the staff of the college take lunch. They offered us to have a kind of a buffet somewhere else. I said, no, let's have the same experience as people in Oxford. Sometimes we think about them as aliens or something. They are normal people here. So we thought that. I hope you enjoyed the lunch. So our next speaker is a entrepreneur, somebody who has vision about making things new, and especially trying to start movement towards initiatives around herself. So Mona Hamdi, has a PhD. She's an engineer, of course, and she's a founding member and managing the Intelligent Mobility Future Vision collaboration group. She works actually as a consultant on intelligent system, and she has a lot of connections in the UK, Europe, and worldwide with regard to in academia and also in business. Her interest and expertise mainly in real-time dynamic systems, and she had investigated methods that can be applied to optimize control systems in industry and commerce. I mentioned a few things of her long CV, just so that I found actually her biography is in the booklet. But for example, she since 2008, when I have been working on solving transport problems by forming roadmap for the future vision of transport and mobility. Her focus is on transport system integration and multimodal travel. And with that in mind, she founded the IMFV. One area of, that's interesting that shows that although she is based in the UK, her interest goes beyond that, and that's why she is participating hugely in initiatives in the Middle East. And as such, she also established the future vision in intelligent mobility of the Arab region. Also, she, as part of this, She is a member of the Arab Scientific Community Organization, ARISCO, which is on the consultancy board, and director of research for the ITS, Intelligent Transport Systems Arab Organization. So wide range of expertise, wide range of interest, and I hope that you will share this with us today.
Many thanks, many thanks. I'm sorry that I made it very difficult.
No, not really.
All right, let's start. Thank you very much for inviting me, and thank you very much for the introduction. I have borrowed from the conference some terms for the title of the presentation, which is the association between mobile application into the future infrastructure and its application to transport. So the focus would be on transport of the future. First, I'm going to give very fast review for what is Intelligent Mobility Future Vision Collaboration Board, and some projects which is focused on the priorities of Intelligent Mobility Future Vision, which is integrated, truly intelligent transport systems. And then I hope I have enough time to give an example of the smart application for transport. So that is the aim of the IMD, is to have easy travel integrated through the intelligent transport system. Now, if we look at transport systems, there are complex systems of systems and networks, multimodal, involve logistics, involve lots of things. And technology is moving fast, and a lot of new ways of travel are developing. However, we need to look how to improve the journey experience for the traveler. And that is not only by using technology, but also by providing comfort, but for example, by how to design inside the rail compartment and the bus, what information to provide, how to design the stations, and where, to do some Danish, I think, or Dutch have designed even the bin when you cycle in a right angle to throw your rubbish in it as recycling. So where to put the station, the bus station, railway station, where about in the city, how to design the city, the region, in order for those interconnections, that network to function efficiently. So that's what we're looking at. It's transport in relation to technology and planning. So this is the situation at the moment, and we would like it to be like this. And the local authorities and government now trying to improve those modes of transport, walking, cycling, and public transport. And this is the Paris map where the new metro stations are developed. And you will see all this movement now all over the world and Europe to solve congestion problems. So that's where I started in 2008. Is looking into ITS, Intelligent Transport Systems, and as I'm with my background in artificial intelligence and intelligence systems, I didn't think they are intelligent or intelligent enough. I didn't think that there's true intelligence. It's not applied correctly, or it's not monitored correctly, or calibrated correctly, and the way it's implemented is costly, ineffective patchwork, no supporting policies for transport systems, and there's no adaptive long-term planning as well. What we needed is multimodal, integrated, interoperable, dynamic, proactive, reliable, real-time systems. So the question was how to achieve that. At the time, the Technology Strategy Board was talking about seamless travel. So we started an event to ask the question, is seamless travel commercially viable vision or just a dream? And that's when we started. We need to think outside of the box. We need to think what technology will provide us with. And really, we shouldn't think just of transport systems, but of the end goal that we have a smart living environment. How can we approach that in a holistic way and apply all the knowledge, all the technology that we have in getting that system to really work efficiently and intelligently? That triggered the collaboration group, which is started the network and the research collaboration with commercial entities forming out of the ideas and the collaboration. And it started by growing internationally. So the focus is not only on the UK, but it is definitely having a UK core. And the idea is the vision is so complicated that we can't really build it on our own. We need really to have all those expertise, multidisciplinary expertise, to put the jigsaw together into solving the problems. So we started building the stakeholders, the users, the beneficiaries network, the expertise network, the investors network. All from their angle will look into the problem in a different way and contribute into solving the problem. So that's the idea of IMD network. So with having open data, we have a lot of possibilities that we can now work with the mobile technology and all those data. There is a lot to do in order to make this habitat a friendly place. And we need to do it in a way which is not biased to a certain industry or a certain company. So we try as much as possible to have an unbiased vision to the future. And that's where we start by looking into monitoring economic, social environment. What is the problem? How can we fund it? Can we come with innovative ways of funding it? What are the requirements and needs? How can we link it to the social, economic, environment policies, both environmental land use, so all the planning, the environment around it, short and long-term planning are needed, and what are the technology enablers, and what are the standards, and finally the business plan. Can it work? Is it going to be used? So all that effort is going to be part of solving the problem, and I would call it the IMD domain, or the problem domain. So this is from the traffic center information management. You've got three functions: the monitor, you control, and you inform. And that's what constructs the travel management on all the information from the sensors, etc., for this travel management center to provide services and applications. The market is huge: infrastructure, personal, and commercial. Any applications and services need to have a business case, and you need to have user acceptance. When would the user accept it in order for it to be successful? To me, as a personal priority, I need it to be safe, I need it to be reliable, I need it to be green, I need it to be comfortable journey. Thus, then I will use that system. If it is a bus, then I will use it because I trust the system. Hence, we have a lot of issues since 2008 being processed, which to do with accuracy, security, privacy, and ownership, from multimodal resources that need to be joined together in order to manage to predict relationships, behavior model, and predictions, in order this information to help in the management of the system and inform also as well the traveler. You probably will not be able to have a seamless travel, but at least you will need to minimize from the stress from disruptions and changing of journey. So, in abbreviation, the transport system is complex systems in unpredictable dynamic environment. And that's the whole idea that we're going to work with. how can we manage unpredictable dynamic environment? Just one thing, that this network have started social networking on LinkedIn and got a discussion board with 2 subgroups for each project. The project that we have is the Autonomic Systems Road Transport System project, and we have started a demonstrator consortium, Autonomic Wide Area Network Manager. And we have also the Intelligent Mobility Future Vision in the Arab region subgroup, and this is for the second project. It's actually a program of projects. And recently we have launched the IMFD in your region. And that's different because we have different members in different regions. We cluster it together in order to solve problems in that region. So if you're interested in joining and you would like to improve the mobility in your region, please let me know and approach me. I'm going to suggest another subgroup as well for at least to start in LinkedIn, which is Ngmast for transportation. Hold this thought because there is a project for it as well. The project number 1 that we're working on is for autonomous and autonomic systems, or the Autonomic Wide Area Network Manager. It has been launched recently, and we're building the consortium for it as well, and attracting attention because now we're researching mature enough to start testing the autonomic system. It's led by Professor Ian McCliskey from University of Huddersfield, but that doesn't mean that IMV is owned by University of Huddersfield. We have many university members, and it's really IMV is a network of many specialities, including an SME-centric flavor in it. The IMV is acting as dissemination and exploitation for the autonomic road transport system, which is a project with 44 Euro countries. So, where would the autonomic systems are used? It's used to manage complex and also which is where systems where human control and access is not easy or possible, like space and sub-area. So complex systems. And there's special attention and funding for the UK for it at the moment. To define the difference between autonomous and autonomic systems have the capability to communicate, control, and decision-making that enables the function in unpredictable dynamic environment. And that's the environment that we're talking about, is unpredictable dynamic environment. Autonomic systems have the same capability. In addition to it, it has self-management capability, self-healing, self-configuration, self-protection, etc. So, if we have complexity and we're still managing software in such an expensive way to implement and maintain, then the reliability will go down, and we have the problem that we are really we're having a technological giant with a child brain. And that is the problem that we're going to face in the future as the complexity of the system increase, as the data increase, and the management of this data and information and interrelated systems, connected systems increase. So, in order to have green, sustainable, dependable, on-demand transport, then we need to improve the reliability of dependability, which is a measure of systems availability, reliability, and its maintainability. We are heading towards autonomous cooperative vehicle systems, and we imagine the future with autonomic system engineering managing all these resources, and this is constrained with self-management abilities. Now, what are the challenges that involve such a management system? Can we really achieve reliability? And that is the challenge. That's what the Autonomic Road Transport Group is investigating at the moment. The difference between current traffic control systems, for example, which manage planned and unplanned incidents and disruptions and traffic management, is that the autonomic system aims to have also management of higher level planning, allowing management prevention capabilities. So if, for example, the manager introduces a new policy and this policy conflict with the goals of the system, then the system should let the manager that this will have consequences which is undesirable. So really, travel decision making is highly dependent on higher level decision making. So my decision is very much depend on the operator who manage the travel network. So if the operators have ability to manage the network properly, in the end, my travel will be much more comfortable. Going back, this is what I mean by truly intelligent systems. And when I talk about intelligent system, then I'll talk about adaptive to change with the ability to perceive, learn, optimize, predict, plan, and manage, and detect conflicts. Once it detects conflicts, then it will advise the operator on what to do. There may be many options, and he or she needs to make a very fast decision which option to take and what is the consequences. This is when they need advice. However, if we go a step further and actually the system would provide the action, then is this action trustworthy? And that's what the Autonomic Road Transport Group at the moment trying to investigate for the future autonomic road transport system. Again, we are now in the process of building demonstrators, and we welcome interested parties in research and business to come and join us. And that's not for just IMD, but also for Autonomic Road Transport Group. Now, the second project, do I have time?
Yes.
Very good. The second project or program of project, because it scan over the Arab region or Middle East region, is how can we build a model that we can follow and learn from? Future build smart environment and intelligent transport systems deployment. Arab region is from Iraq and some Morocco and part of Sudan to the Mediterranean Sea. That's many people don't realize what we mean by the Arab world. So why did I choose the Arab region? And what is the benefit of having a unified Arab regional strategy? And what is the benefit of having EU-Arab region collaboration? To summarize the Arab region, like other developing countries, there is no legacy systems or little legacy systems, and they are all building new. They've been building the infrastructure, they've been building new cities, so it is like a canvas for building the vision by avoiding the mistakes that Europe and the rest of the world have done. So this is a place where we can really build a vision. Now Europe now preparing for cooperative systems. Hence, rather than building the infrastructure for such a region, looking at the current system, we need to plan today for the future. We need to plan for cooperative infrastructure. So the future is for this region, it could be identified, the division could be identified by knowing what are the requirements, the problems, the challenges, and what are the solutions in line with international standards, and that's very important, adaptation and support of cooperative systems, technologies and services deployment in the MENA region. And the adaptation bit is hugely important, and we'll come to look into why. Now, when I started working with the ITU on priority ITS applications and the requirement, the communication requirement and security requirement for the infrastructure on ITS applications, that is the categories that I came up with, and it is really a work in progress. And I welcome more input into that. It's applications related to economy, applications related to safety, national security, environment, and infotainment. As a conclusion, what are the priorities of intelligent transport systems application in the Arab region? As the rest of the world, safety and law enforcement is number one. Emergency, disaster, incident demand management, real-time, multimodal travel information, and most importantly, that I'm highlighting here, is information-based behavior management. How can we change behavior to support, for example, people to obey and confine to safety and law enforcement? So education, changing behavior is important. And I'm highlighting also another point with integration with smart infrastructure. Again, we cannot look at it away from urban planning and smart environment planning. Now I'm looking now to form a consortium for Horizon 2020 for Arab-EU collaboration. And basically, I'm looking for how to implement the new technologies and how with some sort of twinning ideas of Arab and EU, where to implement it, which technology, when to implement it, and what are the supporting policies that we need, what are the standards that we need to support, interoperability, and how to enable interoperability, liability, or how to ensure interoperability and liability, and the appropriate standards are used, and what is the viable business case. And when we do it, we scan on how we can immigrate from legacy systems through the current new systems and look into the future for cooperative systems and other modes of travel. In doing that, we are thinking really of gradual implementation rather than sudden implementation. Case from Tunisia. This is from the Tunisian case study. Again, they will see multi-modal national traffic and travel information systems come to the front of a requirement in Tunisia, from even information that's related to policy network, aviation, maritime network, weather information, etc. So now we look at it and combining all those information together. So what we learn from going to the Arab region and other countries, we're pushing the boundary of research and technology, particularly in those regions where there's not enough money, and now money is the question even in Europe and the UK. So that makes us think what else we can get out of technology. How can we use it? How can we push those boundaries? How can we find new ways of investment that will fund the research? And really, one of the most challenging case study that we have is the Palestinian mobility model, which again we are pushing the technology to come. Okay, this is a very difficult problem. How can we use technology, and how can we use new ways of thinking and to getting technology to make mobility easier in the West Bank and Gaza, with all this dotted West Bank, let's say, islands of West Bank, and especially that with the telecom and the main roads between them, it's not mainly not under their control. So how can we push the boundaries of technology to make it easier to get the people to the degree that they can build it themselves, not very expensive, and as it is a war zone and very often get demolished, how can they rebuild it again? So again, it makes us thinking of new ways of doing things. So those, the benefits, which is really a summary of why the Arab region and why the collaboration with Europe is necessary, is first, we are implementing a vision of harmonized, well-integrated model of transport sustainability that we can take to other regions, for example, developing countries. It's ongoing knowledge transfer process, opportunity and economic impact, and generating creative new ideas, new challenges, force you to think in a different way. And example also from the Arab world, which on mobile applications, is now collective mobility. And really, collective mobility have been encouraged and pushed by mobile applications. It was, I would say, enabled more, especially in Western world, by mobile applications. So, what the revolution in mobile technology provides dependable, on-demand information that will resurrect the culture of sharing in the Western world and Europe. That is the question. What can we learn from other societies, such as the Arab societies, which sharing is very natural in them? For example, I used to lend my car. A lot of people lend their cars in where I used to come from in the Arab region. And sharing principles is well defined there. However, in the same time, there's a lot of from the Arab also to learn from Europe. For example, they would not share the petrol. If I ask Arabs to share the petrol with Germany, they think it's an insult. So again, the Arab behavior have also to change. So it's change of behavior from two worlds, which may be enabled by the new technologies, new mobile applications. So what do we want to achieve? We want to achieve reliable, safe, on-demand, secure, and cost-effective solutions. Especially with shared travel, it's very important to feel safe. For example, especially with a woman traveler, is moving very slowly into the Arab world. Only the Gulf have used it, and probably I would say not the native Arab in the Abu Dhabi and Dubai. However, again, shifting the way of thinking, higher parking fees, new parking policy is pushing them into thinking, okay, let's share. How do they travel? That's not only in the Arab region. I think a lot of developing countries have the same minibuses and taxis. So can we adapt the current use, the way they travel using mobile technology? That's another question. How can we use this technology into improving the current way of travel in their culture? Tunisia, very much getting techy. There's Android clubs. The young people are really thriving with new ideas. However, an example of bad policy. Bank loans are the first financial source to buy a car, and they're encouraging it. They're giving easy loans, and that's the same in Palestine, and that's the same in Egypt, and it's a huge problem. And that is when policy doesn't work well with progress. And that's why having a government as a stakeholder supporting the good mobility policy is important. Cairo, they have sense of humor. They're 80 million, and Cairo itself is above 20 million. So a lot of pollution, a lot of car jams and wasted time. So they use this joke and humor to get them all let's go all together in one car. And I love it. I love the way they're trying to change behavior and change the way of thinking. And they are doing a lot of applications with lots of options about traffic congestions, crowding, overcrowding, and social activities, traffic maps, etc. And what it's in Arabic, but I think it doesn't need translation, is how to persuade them actually to share the cost of travel.
واقف بعربيتك في الزحمة في كام واحد زيك رايح نفس المشوار وكام مرة كنت عاوز تروح الساحل في الويكند بس مش معاك عربية أو مش عايز تسوق.
So you have all this problem of you want to go somewhere.
يعني لو في حد رايح نفس المشوار ممكن
if you go the same way as somebody else, then you can share it.
هتلاقي ركنة بسهولة.
And then you can also easily park, because less cars in the road.
وكل ده مش هتبقى لوحدك في الزحمة.
And if it takes long time, you're going to charge.
وأكتر كمان. هنزود لك خاصية الثقة بالسائق. الدفع بلا حرج والأول مرة في مصر سهولة الحصول على عائد مادي وبكده هيرجع لك حوالي فلوس البنزين أو أكتر كمان.
Making it attractive to actually ask for a charge for giving a lift.
قريبا على التليفون المحمول. انتظرونا.
So that's how they're marketing it. Not only you're going to share the ride, but you're going to actually have some money out of it as well. And they are also having options, filtrations of matching which community can be together, and things to do with security. And security and safety is very important in it's provided as part of the application. Women-only groups, smokers, air conditioning, music, etc., age group. So it's two things to highlight from the motivation. It can be support for public transport, and also from one of the main targets is car sharing information should be integrated to total modes of travel information. I'm going to abbreviate that because there's all sorts of targets and car share, because those are the most important, that integration of multimodal travel information, and as well finding other ways of collective mobility other than the public transport. So we conclude, as a conclusion, that other countries doesn't have to follow the European Western model of travel. The technology, mobile technology, can provide new ideas that suit their cultures. And in consequence, we will find new ways of doing things and new technology that we can take it elsewhere in the world. And this is really the whole idea out of all those slides. So those are proposed studies. It's intelligent taxi and minibuses, and also what are the main properties of sharing cultures? What are the enablers that enable you to share a car or taxi or any other type of transport? And also, Portsmouth is a wonderful city to do car sharing, and unfortunately, it's still very amateur and premature. It's a small city with no car parks and always bottlenecks in the traffic, so it's ideal city for car sharing and cycling like the Dutch model. So in conclusion, what we need to think that intelligent transport system is part of the smart infrastructure. We cannot look at it in isolation of the smart infrastructure. And that means it will allow us to reach out for solutions that are beyond the capacity provided by the current transport network. So we need always to be looking ahead. What are the technologies? What are the future technologies? And what are the future standards when we're planning for the future transport network and systems? And just to remind you that I think, especially with communication requirement and security requirement for the transport infrastructure that we're looking at, I would welcome the Ngmast group to participate in IMD, looking for the future applications and its requirements, communication, security requirement, what is the future infrastructure, what do we need, and maybe experiment in areas like the Arab region and development countries. Thank you very much.
Thank you very much. Before taking questions, actually, it's amazing that the keynote speaker in the morning, who was very technology oriented, again brought the examples about where 5G needs to be active, and he mentioned transport system and intelligent transport, saying that actually it's a big problem. During the break, also, we were talking with a colleague from Oxford University here who is working on big data. And the example we were talking about is the transport system in large cities in China, and saying that this is maybe the priority, because any small improvement that we can do on this can make a big difference. Transport touches on everybody's life. So thank you very much, Mona, for the talk from your perspective about transport systems. So can I take questions? Questions? Yeah, please, no?
Thanks very much for the talk. It's a very interesting talk. I'm just wondering, how do you deal with the human data? I saw very interesting case you have Palestinian models, and especially in the war zones. It's human data is very sensitive kind of data. So this is my question. Do you have any specific suggestions about how you can deal with human data, especially for smart city? The next question is about the privacy. So it's not about talking about we can achieve intelligence in smart cities, but the problem is how can we do the data analysis how can we achieve the intelligence cities, smart cities by data analysis without intrusion of human privacy? That is my second question. Thank you.
So I think if I understand the question, it's about how we're going to deal with
how do you collect data
privacy.
Human beings, or is only machine data?
Only
machine data.
Motion data.
Machine
data. Right. Yes. Well, this is an issue which have been discussed and still being discussed in many aspects, especially with the standardization, especially in security and privacy experts. For example, sometimes you share data that you think it's harmless and wouldn't give away any privacy. However, when you fuse the data together, you start looking at it, then you find out, no, it does touch you. And one example was given about one logistics company. They realized how much that the industry produce from the number of cars or lorries distributing from there, just by putting the data together. So this, I'm not an expert in it, but there is expert in it, and I think Scott Gazzo, who's going to present for IMD on Friday morning. He is, I think, more qualified to answer this question than me. This is an issue which is still, I think, brewing.
Actually, when you mentioned intelligent taxi, the first example that came to my mind, given that we are working on mobile applications, was the Uber app. You're aware of the Uber app. It reminded me about the readiness of the market. You're mentioning about intervening with and working with the Arab world about leveraging their infrastructure in order to reach this smart transportation system. But the problem with such apps, just like Uber, it's proved that even in the UK and the Western world and in Europe, they are not yet ready from legislation and legal systems and acceptance of such systems. We are hearing about how taxis in London are protesting because they are losing a lot of work because of Uber, such apps. And so the readiness is not there even in the Western world, not even in the
Well, the readiness is not in terms of technology, or is it in terms of technology? It depends on the country as well.
Yeah.
So there's challenges. One of them is culture change, and I think for London it will change, the culture change. It's just taking time, and because the convenience, the travel convenience, it comes on top of that. I mean, new way of collect travel can be also a challenge for public transport. Now, but if you take other countries, like developing countries, where public transport is really very bad, and people have new ways of doing things, and you look at that infrastructure, and you think, okay, with this infrastructure, what can I do with this technology? Yeah, and you start like that, and then working with the government on what else we can do to make this better. So then you know that you don't need to spend so much money in order to build huge infrastructure, in order to improve life. Yeah. And it's really working with what you got and slowly trying to plan. And this is the benefit of planning.
Actually, just like working in new areas, it can be sometimes easier than working in London. In London, there is a lot of interest in established systems, established regulations. It's hard to break into a system. While working in a new platform, as Mona mentioned at the beginning, it can be sometimes easier. I know about a system for taxi calling has been launched, not Uber, in the Middle East, in Ngmast, which is a city growing in a huge pace, becoming 10 million city with no really residents, grown from 2 million into 10 million in a very short period of time. And they're launching a taxi calling system, and collecting data, and no opposition here because there's nothing to worry about. People are not they didn't have any thoughts before, so they didn't object against that. So I think, just to follow on what Mona said, this European Horizon 2020 has a significant pot for collaboration between Europe and other regions, including China is very huge, as well as India and the Arab region. And I think it might be interesting for you to consider if you want to have any kind of partners for your projects from this region. Probably Mona can be the connection.
Yeah, I'll be in a Med Dialogue conference next month, and we'll be meeting with teams from Tunisia and Jordan and who else, and Palestine and other Arab regions. They're all interested in mobility and in mobile technology. Actually, most of them are now in mobile technology experts, and I'm trying to convert them into transport. So please, if you're interested, let me know.
Okay. So if no more questions, thank you very much.
Thank you very much.
So we know that afternoon we need some coffee to continue. So we have a coffee break now, the same room as in the morning, and then we break two parallel sessions, same way as we did in the morning. So enjoy your coffee.
So session B2 will be here. Arto is the session chair. Session A2 will be down there. So if you, the people who are presenting, can you bring your presentation, please?
Basically, what you told you at the beginning, I expected that I had to stop you sometime. Years before Germany before that.
This is the target crowd. Enjoy for. But then again, we're talking about the vehicles, right? We're going to get it into older phones.
We have four already. Peter is here.
Yeah, but I'm sure a lot of young people also use older phones. Exactly. So.
Yeah, just click on this thing.
The standard kind of thinking, like, okay, let's add GPS trackers to buses that, that have people report and stuff. And with other phones, it's just a tumble. It's possible maybe, but much more difficult. You have to do things.
And when you have such a
convention.
And also, when I use it, for example, most people there, it would give you different ideas than the one. And you may end up with new technology and new way of application. Welcome everybody.
At one point, I system I find as a detect track buses basically, we don't have GPS trackers. I have the ability to do that. So we were thinking stuff that we were thinking, okay, how can I do this? Saying let's put a camera in the bus station to identify the bus number or something like that, and you can text the user if he doesn't have a smartphone. Like, makes you think unconventional. It's pretty much random.
Yeah, that's
the territories.
I was looking for this one.
Yeah.
So how can I move it without saying so that's one. And I don't know. good relationship. I don't know whether it's easy for you to get involved or something like that. Lovely.
I'm finishing my PhD, so
So that you are PhD?
yeah. These are interesting problems. People just tend to say, okay, we have smartphones, we have, we can do whatever we want.
I think it's right, but other ways also
yeah.
زوجتي
And you're specifically trying to target developing countries, right? That's because you said that you don't want to work like in Europe and you place it No, but I'm saying because you don't want to work in places where there's always, infrastructure of some kind of difficult to change.
Because you have a vision.
Yeah, in the Western world you always have something.
Just for example, if you want to do a dynamic bus scheduling system.
Yeah. Yes. And now you have operators and it's like...
I was in one of those workshops in the sound system, and I was amazed how they said, why can't we have a dynamic way of you can't.
Yeah.
So also this is for basic planning, because I'm not going to plan pretty
Yeah.
Because it's not only technology. So that's why, because I'm Arab,
IBM was in this smart city vision. IBM had this huge project, trying to design the city basically from scratch. Have the money to do it. So.
We are really small, getting involved in ourselves from maybe I don't want to be names, but I end up thinking ideas of building ourselves. I was surprised.
Maybe in the future somehow.
واكثر سيستم الدكتوراه لما يكون سوبرفيجن كمان كورسز معينه من برا
on transport.
We have a project.
Yes, and what about the car and everything else? More than just a car, you can have this. And also you can have a car. I forgot about this one.
So you have this in your table?
Should be there. Is there, is it?
I'm glad I did it. I got my card somewhere. I think my email is not on the brochure anyway, but If you're interested in participating, for example, in the autonomous demonstrator or in autonomous systems projects or any other ideas,
I'm doing a lot of consulting in China on smart city online, and also I'm consulting one of the biggest telecom equipment provider in China called Huawei.
All right.
Huawei, yeah. They have a lot of equipment, and I'm the one of guys to advise them how to achieve the smart cities, one direction analysis, so all the telecom equipment will be able to, so generally data, and we use a lot of the data that, for example, base stations to detect the weather and to predict the climate change, and also we can predict the mobility pattern, how the people will use the mobile signal. We don't even need GPS because the base stations know how to know.
Well, listen, if it's really interesting, because active people with an ISD will have their biographies in the database and have their CV, and when we have a project, I contact them to form the consortium. So if you're interested, because then suddenly we have a project I will come to you and say, well, would you be interested to be part of this consortium? Also, as I said, in the Middle East, there's now China is interested in building there. So would they also, so would they like to be part of IMD in the Arab region? And the third thing that I know is a student now on autonomous system, which I wanted to build a consortium for autonomous car model. If you're interested in that as well, then we should talk. Exchange emails, yeah.
Also, I mentioned you in the last time working with Chinese science in China. We have phenomenal data in large scale cities. The cities handling populations because all the real-time data in terms of all the taxis. We have GPS enabled, we can get signals for all the taxis, also the bus and the underground systems.
I mean, if you'd like to send me information where I can read about these things, if you have brochure or you have somebody else, so I will know. And then I will, if I know, then I'll come back to you with an idea. Yes, I mean, we are now building the like consortium of the smart cities in the Middle East. So it will be fantastic if we join us. Yeah.
Okay, no problem. So I will send you email.
Yeah. Please do.
Okay.
Don't lose it.
Okay.
Because one of the areas I want to use is autonomous biometric systems, and it's a security focus, but I've looked at autonomous systems in general.
We've got a lot of other applications as well, but at the moment myself, I'm focusing on software, but it's possible also to go to other areas, especially focus on networking. So if you're interested, please. Let's talk. I mean, do you have a special interest or special any questions?
Not specific, it's just looking at it, I thought I'd like to know more about that. It sounds
I just started this week a subgroup in LinkedIn, and I put a link there for publications. You'll see in the this slide, which is I borrowed some of them for this, and you'll see the brochure as well, and contact me if any questions. And also, I would like this subgroup to be more focused about the main group because just works. I'm going to try to categorize and have subgroups so people will really seriously discuss things like that. And also, listen in, if you have any codes, any questions, if you want to write, I'm going to read these series of codes.
Yes.
You have a little bit more seriousness.
Yeah.
Rather than just, just networking I'm here, I'm a consultant. Yeah. And this is the need. So, that's one way, but Professor Masis is wonderful guy to work with.
Very
We have another guy also coming. He's not an economic person, but he's a standard and security person. He's coming on Friday morning at 9 o'clock.
Yeah.
What's that, sir?
Yeah, I know. Okay. That's what I understand. Thank you.
Thank you. Kappa.
It's really hot. it's always the same in sector. I always get much more further.
You're from around here?
Not around here, up north. Whenever the children go back to school after the summer break, it becomes a lot.
I guess it's quite moist also the air. Because in Finland and from Finland, when we have plus 20, it's not nearly
yeah.
or it doesn't seem to
this is an odd time because we normally this isn't kind of what we're used to. It's normally a lot more dreary and rainy.
Really? When I was in London last time, that was normal.
No, I think I was in London in the October. There was a conference and then it was okay. It wasn't that hot. It was quite nice. Yes, and the last one. Yes, it's me.
I was recruited this week.
I think I should be later in the week or I need to get a whole so roughly maybe chairs with the operations help. Maybe from one of the universities. Yeah. That's when are you finishing?
Hopefully in 2016.
I've got 8 weeks. 8 weeks, and that's when I submit my final thesis. So it's always good fun.
Is this your final paper?
No. I've got about 3 other ones yet to come. So I've done it by time. So over the years, I've got the third one. Yeah, that's the bonus of doing it part time. But yeah, it's good. What are you?
I would say computer science. Multimedia. So distributed.
Are you living alive? Are you alive? Instead of doing a plastic hand, for example. Instead, whereas there's a lot of research going on making fake fingerprints with gelatin and wax and plasticine.
Right.
So it's a way of detecting if it's proper living.
Okay. So related to this fingerprints.
Fingerprint, iris, facial, vocal, the forms that liveness is a fairly common factor now throughout most biometrics. The ones that work anyway.
Okay. We have our four speakers ready. Just click on the link. Sure. Okay, ladies and gentlemen, welcome to the session B2 on the topic of positioning and localization. My name is Alba, and I'll be the chair of this session. And the topic of the first presentation is accurate indoor positioning system using near ultrasonic sound from the smartphone. And it will be presented by Shotaro Murata from the Kanagawa Institute of Technology, Japan. And he received his bachelor's degree in Information and Computer Sciences from Kanagawa Institute of Technology in Japan 2012, where he is now a master's degree student. And his current interests are indoor positioning system using near ultrasonic sound from a smartphone, and he is a student member of Information Processing Society of Japan.
Thank you, Mr. Chairperson. Today, I will tell the accurate indoor positioning system using near ultrasonic sound from a smartphone. This is the content of my presentation. At first, I will tell the background of our study. Next, I explain the positioning principle and system architecture, component design, coordination of sound reception, and the positioning experiment result of the proposed system. I will show the demonstration video. Finally, I will conclude my presentation with brief summary. Many kinds of indoor positioning systems have been proposed. Wireless LAN, RFID, camera, inertial sensor. Some indoor applications require higher accuracy than that needed for an outdoor area, because the width of doorways and corridors is small compared with those used outdoors. However, no common system has yet been established, and various possibilities are being investigated. This slide shows the size of usage area and required positioning accuracy in indoor area. High accuracy of indoor positioning is required for some applications, such as navigation for visual impaired, etc. Positioning system based on sound is one candidate for satisfying experiments from aspects of positioning accuracy. These slides show our development motivation. The authors have been investigating a positioning system based on the use of ultrasonic sound. However, these suffer from a shortcoming in that users have to possess a special ultrasonic sound, ultrasonic transmitter. Smartphone is scaling rapidly for general users as a communication tool, so no special equipment is necessary. In addition, it has many functions. This feature provides advantages from the viewpoint of application development using positioning results. This slide shows the system configuration. The left system is positioning system by using ultrasonic. This was built in last year. The timing data of the sound are sent to the PC positioning. This proposed system in which the smartphone is used as sound transmitter. The 70 kHz sound is used at this time as near ultrasonic sound. The different system components from the system of last year are indicated by red letters. The microphone sensors are used instead of ultrasonic sensor. Near ultrasonic receiving units are newly developed. The positioning calculation software is same in last year. This slide shows the positioning principle. This is a sound transmitter. This is fixed in moving object. The sound is detected by these microphone sensors. The location of these sensors are displayed by XL, YL, SL, and so on. The clock of the sound transmitter is independent of the receiving unit. Therefore, the absolute propagation time cannot be obtained. Only the relative delay time at each sensor can be detected. Free delay time can be obtained from all receiving sensors. The following mathematical equation can be derived by considering the distance between a sound transmitter and each sensor. Unknown positioning of sound transmitter that is x, y, z, and propagation time t. Therefore, at least 4 sensors are required for solving these unknown parameters. This system does not need to synchronize between transmitter and microphone sensor. This makes it easy to compose the system. This is an example of sound transmitter for positioning. Interval 35 millisecond duration and 400 microsecond burst sound is used at this time. Next, I will talk about component design. A smartphone is used as a sound transmitter for positioning. Sound is generated based on a WAV file. Sound data is given by following expression. The built-in speaker in a smartphone is different for each model. The Sony Ericsson Xperia was selected after evaluating the transmitting performance. This slide shows the receiving unit configuration. The microphone sensor has broadband frequency reception characteristics, so it is affected by environmental noise. Consequently, a bandpass filter which removes the environmental noise must be used in the receiving unit. The output of the sound detecting circuit is transmitted to the PIC microcomputer to detect the timing of the sound detection. This is a picture of receiving unit. This is part of the amplifier. Filter circuit and AGC amplifier. Temperature sensor is used for compensation of sound velocity. At this time, the frequency for the timer count is set at 2 MHz. So the time resolution is 0.5 microseconds. Next, I show the combination results of sound reception. This slide shows the result of sound generation and projection. To begin with, the sound frequency from the smartphone was examined. The sound from the selected smartphone was measured using FFT. The output of the designated frequency sound 70 kHz was verified by this measurement. A 400 microsecond burst signal transmitted from the smartphone at 35 millisecond interval was also verified. Based on this result, the threshold level for sound reception was set 1.0 voltage. This slide shows the experimental configuration for achieving time detection. The most important point for accurate positioning is correctly detect the receiving time of sound from the smartphone. The evaluation test for the receiving time was carried out using 5 receiving units. The distance between adjacent microphone sensors was chosen to confirm the difference in the receiving time of the sound signal. This slide shows the experimental results for time of receipt. Evaluation tests were carried out in 2 different environments. That is quiet and noisy environment. This is the theoretical values. It was verified that the burst sound from the smartphone can be detected correctly. This result guarantees the possibility of precise positioning in a noisy environment. From now on, I talk about the result of positioning experiment. At first, I show the view of experimental setup and environment. Left is quiet environment. Its location is laboratory room. Right is noisy environment. Its location is cafeteria. And time is lunchtime. The metal frame structure was used to install microphone sensors. 5 microphone sensors were used in this experiment. The smartphone was placed on the base, and its position was measured to evaluate the accuracy. This is the result of static test for positioning accuracy. This is the position of smartphone. Positioning error is very small, especially in quiet condition. The deterioration in noisy environment seems to be due to detection of environmental noise. The positioning results are summarized in this table. Here, PE means positioning error. SD stands for standard deviation. SR means the success ratio. The error was within 4 mm in the XY direction and 5 mm in the Z-axis direction in the quiet environment, 3-dimensional positioning. It was also verified that the errors less than about 20 mm in X and Y direction were obtained even in the noisy environment. Positioning with high accuracy can be confirmed in static tests. This is a picture of the positioning solution sequence. The positioning accuracy is decreased due to noise or multipass effects, which cause some direction errors. Count values that seem to be improbable may be considered to be errors and can be removed. In addition, Ngmast solution can sometimes appear from the numerical calculation. Positioning results are obtained after checking these points. This graph is the result of dynamic test on railway track. In this experiment, a model train with a smartphone attached was used as the moving object. The railway track formed a continuous loop below the microphone sensor. The result illustrates the shape of the railway track in both quiet and noisy environment. The number of points plotted in the noisy condition is fewer than that in the quiet condition. Precise positioning results of the moving object can also be obtained in both quiet and noisy environment. This is a demonstration video. This video is a demonstration of dynamic test. This is configuration of positioning. Positioning PC receiving me. This is a moving object on railway track. Moving object and smartphone. Configuration of receiving side. Microphone sensor. This is dynamic test for moving object. Positioning PC. Positioning results are displayed in real time. Positioning results. The results illustrate the shape of the railway track. This presentation has proposed a positioning system for a wide indoor area based on the use of near ultrasonic sound. The main feature of proposed system is to use some smartphone as sound source. The accuracy was confirmed in both quiet and noisy environments, and the positioning performance has been maintained in a noisy environment by the use of a filter and a proposed positioning solution sequence to exclude anomalous results. Dynamic tests using a model railway track show the effectiveness for use with moving objects. Discrimination between the positioning of multiple objects is an area for further study. Thank you very much for your kind attention. Questions?
So was the microphones in the sensors on top, or was it in the phone?
I'm a co-researcher. I reply. Question is the location of the microphone.
Yes.
Speaker, not speaker, microphone.
It was the microphone.
Microphone is attached to the ceilings, in the frame, top of the frames.
Okay.
Questions? So, we're speaking about the available localization methodologies, the other localization methodologies that's indoor, such as, for example, Wi-Fi triangulation or those kind of methodologies. What are the benefits and what's the viability of implementing this in the meantime?
Yeah, we think that the accuracy of the Wi-Fi is at most within a few meters. So the high accurate positioning is quite difficult if we use a Wi-Fi. But this, as you know, a few centimeter accuracy we can obtain, even if we were using the ceilings, not the frame. In the ceilings, the sensor is attached in the ceilings. We confirm that the accuracy of a few centimeter accuracy we obtain. So the accuracy is much more better than the Wi-Fi, we think.
Yeah, and the viability of implementation, can this be implemented in real time?
Real time, yeah.
Is it cost effective, for example?
Yeah, of course, cost effective. Of course, the Wi-Fi is no cost because Wi-Fi in the ordinary house and ordinary office Wi-Fi is installed. But we, of course, we must have the ultrasonic receiver. Receiver. But the part is only not so expensive because mainly low frequency part very not so expensive. Ordinary part.
Thank you.
Okay, so the title of the next presentation is REAR towards infrastructure-free indoor localization via dead reckoning enhanced with activity recognition. And it will be presented by Andras Nagy from Zoltan Nonprofit Limited for Applied Research, Hungary. And he received his bachelor's degree in electrical engineering and is currently a master's student in the same field at the Budapest University of Technology and Economics, and he is specialized in embedded systems. He started working in a research group at the Zoltan Nonprofit Limited for Applied Research in Budapest on the topic of indoor localization through using.
Thank you very much. Dear ladies and gentlemen, let me introduce our work on pedestrian indoor localization. We have constructed a context-aware indoor localization framework based on the analysis of inertial sensors signals found in common smartphones. Our aim was to combine two techniques together, the pedestrian dead reckoning and activity recognition. First, I'm going to talk about other results in the research field. Then I will introduce our main concept and give a detailed description of each element of our system. Last, I'm going to speak about our evaluation methods and results. There are various methods in the literature in the topic of indoor pedestrian localization. These solutions, so nowadays there's a common trend to fuse dead reckoning with other solutions. These solutions usually require a significant amount of configuration or infrastructure. For example, in order to use Wi-Fi fingerprint maps, a detailed mapping of the electromagnetic field is required. Others use cameras to recognize certain logos or signs, but in order to apply this in practice,
an up-to-date database of such landmarks is needed. There are solutions which are unlikely to widely spread in public. For example, it is much more comfortable for an everyday user to have a smartphone in the pocket than to wear foot-mounted sensors. Our solution only requires the knowledge of the underlying map structure. Our results show that good quality of localization can be achieved without configuration or infrastructure, which I've mentioned above. First, I'm going to talk about one of our main ideas, the so-called topological anchor points. When the user crosses indoor places, his or her smartphone senses motion patterns. These patterns are connected to the movement of the user, and if they are recognized, they can be connected to certain landmarks of the map. We call these landmarks topological anchor points, or TAPs. If we recognize these landmarks and know their location, it can be used to refine the estimated location of the user. I'm going to talk about this in detail. All our algorithms run on a smartphone. On the whole, our system consists of the following components. The context model provides information about the map and the user profile. The two main sources of location information are the activity detection and the dead reckoning modules. We have formed a hidden Markov model to solve the localization problem with these tools, and then on this figure it is represented by the so-called context interpreter, the error model, and the zone and dead reckoning matching module. Now, let's see the details of our dead reckoning and activity recognition methods. The quality of these methods in the pedestrian case very much depends on the smartphone's position on the body. We have decided to place the smartphone above the hip of the user in a pouch and a belt because it is very easy for the user to install, and the movement and the motion of the hip provides a very good quality information about the movement of the pedestrian. We are using here simple dead reckoning methods to calculate the heading and the displacement of the user. The activity recognition task has been interpreted as a classification problem. We distinguish the following cases. The user may stand, he or she may climb stairs in both directions. We distinguish taking escalators and walking also. Our method is based on a fuzzy associative classifier, which we use to classify certain attributes of the sensor signals into the mentioned motion classes. We have decided to use 2 seconds long time windows to analyze the sensor data. Now I'm going to describe the so-called context interpretation module. I'll start with the concept of the context, and I will tell you what should be interpreted about it. Buildings and other indoor places have a well-defined structure. In order to describe this, we use a combination of metric and topological mapping. The global map is split into planar zones and zone separators which connect them together. These planar zones can be halls or platforms, while the zone separators can be escalators or stairs. These zone separators practically mean the topological anchor points. The localization process evaluates the so-called context of the user. The context includes the closed environment of the user and all available information about it. This closed environment means the planar zone in which the user moves, the neighboring planar zones, and the TAPs which connect them together. The context also holds information about the user profile. It is not enough to know that the user is located on a TAP. We need an exact location. For example, if we get from the classifier the recognition of climbing stairs, we have to handle it differently if the user is at the first step of a stair or at the last of it. Because of this, we have to analyze sequences of recognized activities instead of single samples. These sequences can be interpreted in multiple ways because the possible errors of the classification process. For example, if we get the recognition of stairs, but we are certain that the user is located in a planar zone, this recognition can be considered to be false. Or if the user is probably in a stair zone, but we get the recognition of a walking pattern, we may consider this recognition as a part of a longer stair climbing sequence, especially if the recognized sequence has stair climbing patterns around it. We can see now that the location of the knowledge of the user's location may help to solve these problems, but that reckoning alone is not enough to do this job. Therefore, we have formed a hidden mapper model to combine these techniques together. Now let's see the details of this HMM. The way the Markov model's goal is to solve the tracking of the user and to provide an accurate position of him or her at each time step. The states of the HMM are the possible positions of the user on the map. Each state represents a rectangular field on the map. We have set the transitions of the model according to our user movement model. In this we have two assumptions regarding the planar zones. The user may move in any desired direction, and we have assumed that the subject is moving at an approximately constant speed at any time. Regarding the TAP zones, the user may move only in the main directions of the TAP. We observe the process through our dead reckoning and the activity recognition methods. So because of this, each observation of the HMM consists of two components, a dead reckoning location and the recognized activity. The probability of observing a certain location from a state or a field on the map is set according to their distance from each other. The probability of observing certain activities at each time step describes the uncertainty of the classifier, and these activity recognition probabilities also describe how we want to interpret the activity sequences which we recognize. These observations are produced at every time window of the classifier, but we have decided to update the HMM only at time windows in which the user moves. This means that the whole process is related to the movement of the user and not elapsed time. We apply Witherby decoding to find the most probable path of the user. If the user crosses a TAP aspect, for example, the most probable path has to include all the states of the underlying TAP zone. This means that if the HMM parameters are set correctly, the Witherby decoding solves the interpretation of activity sequences. It detects TAPs and also detects their exact borders. We estimate the user location as the last state of the most probable path. Now I'm going to talk about our evaluation methods and results for one underground scenario presented in our paper. In this scenario, the movement path of the user starts outdoors. This is an underground station in Budapest, Hungary. So the user path starts outdoors, then it crosses two escalators to reach the final destination platform. Along this path, there are two decision points. At these decision points, the system has to decide between the TAPs which the user has crossed and other TAPs which the user hasn't crossed, and these two can be confused with each other if the system doesn't work right. one decision has to be made at the end of the first hole in order to find the first escalator, and the second decision has to be made between the escalators to make a proper right turn to the final platform. This figure shows the location errors in function of time for this one scenario. In this figure, we had only one experiment. The user went through the path only once, but we plotted the results for different interpretations of the same activity sequence. For the scenario, we have recorded ground truth points in order to measure the efficiency of our methods. Practically, these are breakpoints in the user path. Yeah. And there are more breakpoints, I just showed some of them. And these appear as breakpoints in these location curves too. At these points, we could measure the error of the localization method. This error was at each point the distance from the proper ground truth point to the estimated location of the user. Alright, and these ground truth points are represented by black dots and black squares. And the user location is refined by the system at the end of the recognized TAP. On this figure, the gray background shows the time which the user spent on the escalators in reality. These black ground truth squares are the times when the user reached the borders of the escalators also in reality. So based on this, here's an example. The green lines denote the case of ideal activity interpretation. According to this, those which I have already told you, we can see that in this case, the green line, at the end of the escalators, the TAP is recognized, so the location error is reset to 0. For other interpretations, others from the idle case, the vertical lines denote the times in which the user is believed to be at the end of an escalator by the system. In these cases, the length of each TAP, each escalator, was under or overestimated. Because of this, when the system thought that the user in the vertical lines is at the end of a TAP, he was in fact elsewhere. And because of this, location errors appeared. We can see that after the end of the escalators, at the next ground truth points, the location errors of the non-ideal interpretations are always higher than the ideal level of location error. And this is how the interpretations of the activity sequences affect the localization process. On this last figure, we have plotted the same type of error curves for this scenario, but for different motion types of the motion patterns of the user. For example, this means that in each case, in one case, the user was climbing the stairs of all escalators. In another case, the user was standing on the first escalator and climbing the stairs of the second escalator, and so on. For these different motion patterns, we have also plotted. So these motion patterns are denoted by the colors. So one color is one motion pattern. For each motion pattern, we have plotted different interpretations of the same activity sequences. As you can have seen on this underground map, there were multiple TAPs of the same type. If the location error gets too high, these TAPs cannot be separated from the localizational point of view. Therefore, we have defined the maximum acceptable error level for each TAP. These are denoted by the horizontal black lines. For each escalator, this maximum acceptable error means the distance from the starting point of the TAP from the location of the closest other TAP of the same type with which the real one can be confused. Now, as we can see, in the first part of the scenario, the dead reckoning error is so low that it's under the maximum acceptable error of the first escalator, so the first escalator can be found at the starting point. If the system works, the figure doesn't show that it can be found, I just told you, so, but this is the basic information that is under the error. If the system works right, at the end of a TAP, the TAP is fully recognized and the error is reduced to a level that the next decision can be made. For example, at the end of the first escalator, the system recognizes the TAP and the error levels get so low that at the beginning of the second escalator, we will probably find the second escalator and provide a right location of the user. The end point of the second escalator may have been found in or recognized in different times of the user path, but at the end, the location error remained low on an acceptable level. This means that for these scenarios and almost all interpretation of these motion patterns, our method has managed to keep the localization error in an acceptable level. But to sum up, we have shown the method to enhance the capabilities of pedestrian dead reckoning with activity recognition based on in a smartphone-based localization framework. We have showed how activity recognition can be used with the help of topological anchor points, and constructed a hidden Markov model to use these tools to solve the localization problem. Our aim was to confirm that these concepts are useful in the topic of localization, and our results have shown this to be right. As future work, we would like to test our methods for more scenarios and more test subjects. And now I would like to thank for your attention, and if you have any questions, I'm happy to try to answer them.
Any questions?
Probably what were the estimates or observations of the HMM model?
So could you repeat?
Observations for HMM model.
Yeah, that's in slide 13. I actually have the same question about observations. Because I've read your paper and I can't understand as well those observations. What do you mean by those observations?
Well, we have constructed each observation of the HMM to consist of two components. Oh, I forgot that. We have modeled these two processes, the dead reckoning location and the recognized activity, and the activity recognition to be independent, so we calculate their probabilities differently, and the actual probability of their observation, of this observation, is their product of these probabilities. So
what are they? What are they on the real ground? What are those values? What there is in
them? So we said that the HMM, each HMM update comes at each time window of the classifier. At these moments, with each updates, we measure or read the location which we get from the dead reckoning method, and calculate the probe state, the observation probabilities for this dead reckoning location, right? And we also have a recognized activity, and we have defined for all planar positions a probability which describes how probable is it to recognize that activity from a planar location. For example, the location of climbing stairs is not so probable in a planar zone, but it has some probability because of the possible errors of the classifier. this stair climbing observation is more probable in the case of escalators because the user can climb the escalators of the stairs of an escalator, and this is the most probable in escalator zones.
So are we speaking about continuous values or discrete values? Because hidden mark models would like discrete values more.
These are discretized. If there's a word like this.
So there are probabilities, but they are discretized.
Oh, well, all right. So in case of the dead reckoning location, we have a continuous distribution. It is a zero-centered normal distribution to calculate the probability of observing, for example, this location from this shape, and the probability is given by the according to this distribution with a parameter of distance from each other, and the standard deviation is given by our error model, which we described in the paper, but I haven't mentioned it yet.
One standard deviation, or using more than one standard deviation?
Yeah, the standard deviation evolves with the process, and with this we would like to model that the error of that reckoning is growing and growing in all time. So this way, the standard deviation also grows in time, and it gets reduced when a TAP is recognized. So oh, maybe I have something else right now. Yeah. So if we have this dead reckoning trajectory, I may show you the growth of the dead reckoning error with these gray dots, and as you can see, if the red line shows our method, here the TAP is recognized, and the position is refined to be here, and the gray blob, this figure isn't that good, but the gray blob hasn't grown since this moment, because the TAP has refined the level of the dead reckoning error also. And these are presenting these figures, the zero-center normal distribution from which we read the probabilities of each dead reckoning observation. For the second part of the question, the recognized activities probabilities are discrete. We have set them according to our statistics of the classifier, and with some different settings to test our
you have 4 or 5 observations, discretized observations. How many are there?
Well, I think some of this. Then we have these 5 activity classes, and for each state we define the probabilities of these 5 cases in each time step. That's correct.
How much training data you have?
How
much training data you have?
Training.
Yeah, of course. Well, to be honest, the description of the classifier was as a former result of ours, and there were some statistics which we gave a certain amount to change, and these changes resulted in different interpretations. So there isn't an optimal solution yet. We have just tested some different configurations, and it showed that there are differences between each interpretation, because these errors are deferred mainly because of the different observation probabilities, because they define how the TAPs are recognized. That's all right. So for your answer, the whole process hasn't been optimized yet based on training data.
Any other questions?
I have another question already. Sorry for asking so much, but I'm interested in your work, which is the 2 seconds that you mentioned about for taking those values in order to calculate them. Yep. What was the data fusion methodology that you used in order to decide those 2 seconds, and what's the effect of increasing or decreasing this period on the error ratio that you will be, localization error ratio that you're getting? Did you study that, or?
We haven't worked on the topic of changing this time window, but I can tell you why these are 2 seconds. When we were working on the classification method, these 2 seconds proved to be necessary and sufficient to recognize these movement patterns. So if you think through it, in order to recognize a movement pattern of a pedestrian, we need full periods of walking or climbing stairs, a few steps to recognize the motion, and these 2 seconds prove this to be right. You could tell that we may use overlapping time windows, so produce more frequent observations, but that's a future work.
So what if there are more than one firing within those 2 seconds? So how can you fuse this data to produce one piece of data, which is the, because each 2 seconds will be represented by one value to be included in the hidden Markov model. Let's say one vector of values to be represented in the hidden Markov model.
Well, yeah, I understand, but there are strict borders of the time windows.
So what if within this window there are 10 firing of sensors, different sensors producing different data? How can you fuse all of those together?
Yeah, this fuzzy associated classifier is based on rule sets. At the end, so there are rules for the recognition of each activity. At the end, the rule which has the we haven't spoken about this in the paper, but the rule which has the most to prove this to be the most probable according from all other rules wins the fight, and that classified activity is the winner for that time window right now.
That was missing from the paper. I noticed that.
Honestly, I plan to publish the details of the classifier in a other paper. But thank you for the detailed reading here.
Okay, thank you. The next presentation is called Predicting Consumers' Locations in Dynamic Environments by 3D Sensor-Based Tracking. It will be presented by Elena Vilchonat from Technical Research Center of Finland. She was born in St. Petersburg, Russia. She works in the Technical Research Center of Finland in research project related to machine learning, human-computer interaction, and smart environments.
Thank you. So I will be talking about predictive locations of shop customers in the shops. And 3D-based sensor-based tracking is essentially infrared-based tracking by that camera. So main motivation for this work was need for personalized shopping experiences also in brick-and-mortar stores, because online market for online shopping for example clothing becomes very popular, and in online stores they make a lot of tracking of customers' interest and present a lot of personalized offers. And in physical stores, department stores, also the customer interest may be inferred by tracking of visited locations. And then tracking of past locations can help in predicting future locations, and then also, for example, personalized offers can be delivered, or mobile robot or human assistant can be sent to view the customer in the predicted location. And why we use depth sensors? Because they are very cheap, they are less affected by lighting conditions than video cameras, and they handle occlusions and shadows easier because usually they are placed in the ceilings for they can better view. And they are not so private threatening because they don't take pictures of faces. So this 3D tracking system consists of arbitrary number of 3D depth sensors as nodes and the server. Nodes perform object detection and tracking, and server combines views from nodes and performs object identification from one view to another one. That's right. And also detect static objects to help nodes to create adaptive background model. Adaptive background model is needed in order to provide for environments where some furniture can be frequently relocated and generally changes happen often. So it's done by each sensor node, and it updates background model each time when some moving object disappears from its field of view, or when the server informs the node that some object was static for a certain period of time. And the background model is created first in such a way that first, when the system is installed, it's needed to be manually calibrated. This picture shows 4 regions selected for calibration. Then, based on this calibration, height map is created from depth 3D cloud, and then static objects are considered as background and subtracted, and then the remaining objects are considered objects of interest, and they should be moving. And this system was installed in a real supermarket in Oulu, and it was installed so that 7 sensors were attached to the ceiling, and monitored area included female clothing and cosmetic departments, and also pathways to parking space and to other departments. And we collected data in this department store. So server output provided approximately 30 frames per second, and for each frame it provided us with IDs of detected objects, their speed, height, and position, and of course times. And then we needed to develop some applications for this. Department stores and specifics of department stores is that many of them are open spaces where there are many movable racks which can be moved anytime, and also new items frequently arrive, and some old items get frequently relocated, like for example for sales, and promotions also may happen, like one day there is a spend range somewhere and another day not. So this is very dynamic environment. And accordingly, in this environment, regions of customer interest can frequently change. Regions of customer interest is places where customer stops for some time and investigates items. And this figure, this plot shows regions of customer interest extracted from the data in the beginning of tracking and after a few days. So subset A are 2 days in the beginning, and subset B is after 2 days data after 2 days. So it seems that really regions of customer interest change significantly. So also rows of customers in the shops frequently change, and this kind of prevents from using discrete prediction models like hidden Markov models, because it's not so easy to, well, it's needed to extract this regions of interest very frequently, and then there are so many that there is not enough training data to train proper models. And basically, because nearly any place can become region of interest in such space. And also, it's not possible to use the reponent because the person may turn or stop anytime. So we used very simple nearest neighbor based predictions. We extracted regions of interest from the tracks automatically as areas where customers stayed for some time, and these areas were just like circles of limited radius, half a meter, but then we noticed that sometimes the circles are bit greater and they needed to be merged, so average radius was maybe 70 centimeters or so for our in this block. And for predictions, we search for nearest neighbors among recent trajectories of other customers acquired only on same or previous day. This provides for frequent changes in the shop layout. And we only search for neighbors in the tracks which are passing near same location cell as target track. So this reduces computational load. We also find neighbors based on comparing very short track segments, 1.5 to 3 minutes, and used for similarity estimation, position, speed, and past regions of interest in this segment. So this picture shows that target track is blue one, and the green area is the cell where for which we want to predict future location, future point of interest in the target track. And based on similarity calculation, red track is most similar neighbor, And so we take from the similar neighbor its next region of interest, which can be like 10 seconds ahead or 2 minutes ahead, depends on the track. And then we assume that our target track will have same region of interest. And then if you use several neighbors, location and dwell time of this future region of interest are calculated by a weighted average or majority voting of the neighbors regions of interest. And this method was tested offline on the data collected during 50 days in the department store. And before doing any experiments, we interviewed 8 females of different ages, asking them how they do shopping. So what are the types of our interest? And based on these interviews, we found that 2 seconds is quite long enough time to search for favorite items, like coming to a stand, picking up favorite product, like favorite or 10 seconds is long enough time to come to a stand and to detect that this item is missing. For example, there is no blouse of needed color. And 30 seconds is quite enough time to detect, for example, that also possibly interesting item is present. It's not exactly what you need. And so we made experiments to predict this 3 times separate. And we split our data into 2 sets: development set 100 tracks, and then test set 150,000 tracks. And in this set, there were 15,000 regions of interest together, and the average duration was about 13 seconds. And among these regions of interest, 9,000 lasted longer than 30 seconds. For predictions, we split this data set into 25 2-day subsets and made predictions based on for each track only based on the data of the same subset. And we made predictions separately for different dwell times, and we made predictions for every track segment separately, so that we didn't consider, for example, past history of predictions. We evaluated accuracies as if each segment was applied independently for different customers to provide for imperfect tracking, because occlusions make long tracks not so frequent events, especially when there are many present in the shop. And in this data set, when we split it like this as they arrive in the order of arrival, and these subsets were very diverse, because on some days there were like only 1,500 customers in the shop, and some other days there were more than 10,000 shoppers. And also, in some days there were mainly passers-by, and in some other days there were many real shoppers who really stopped and shopped, were doing shopping. And in the experiment we found that on average for all subsets, it's more accurate to use just one nearest neighbor. If we aim at predicting nearly any stop, duration predictions rate was about 70% accuracy, false predictions were about 30%, and distance error was about 60 centimeters, which is quite good for our detection of regions of interest. And this means that traditional way to predict locations of people by making templates from several tracks doesn't work really well for this environment, because there are not so many tracks from which you can make templates, and the tracks are really very much different. And also we found that predictions of long stays are far less accurate than prediction of any state, probably not because only of our method, but also because we cannot predict availability of items. This duration of stays depends on what kind of item the customer was searching. And then we also investigated how this accuracy of predictions depends on data quality. And we found that in the days when there were many real shoppers, like 2 subsets have really high ratio of regions of interest over the number of tracks. Prediction accuracy was fairly high, 75%, and prediction error was again like less than half a meter. And this was very good news for us, because shops are not really very much interested in predicting location of any customer. They interest mainly in prediction locations of so-called exploratory customers, You have people who come to shops to buy something nice, because then they can sell them, convincing that this is nice and sell it. And also these people get more satisfied and can come next time. So this makes real-time prediction more realistic, because you don't need to predict. You can kind of cut off too fast the moving customers, and then usually there are like tens of really exploratory shoppers with the shop at the same time. So we can try to use even more computationally expensive method to predict their future location. So, make, for example, molecular search for neighbors. And but in order to do this, to predict locations more accurately, we need to improve our tracking reliability. It can be done by reducing number of blind spots and occlusions by carefully placing this in the system. Also by improving the identification algorithm and improving object recognition algorithm, because actually reflections affect accuracy very much. For example, if there is shiny patch on the floor, it can be detected as a person sometimes. But generally the system is fairly low cost and it's fairly self-adaptive to those agents. And data was collected in the real department store, which is not a very common case with this depth-based positioning system. Many of them collect data in the labs. And method to continue to predict regions of interest of shoppers also used for highly dynamic environments, because it easily adapts to store layout changes, and it doesn't require extracting sets of discrete location and training models, which is computationally expensive, and it doesn't rely on any assumptions regarding modern speed or direction as usually the draconian methods do, and it doesn't require terribly much computation, because we compare only fairly short track segments, we search for neighbors on the tracks at the same point, and we can cut off fast moving processes. And tests on the real life data have shown that this method is surprisingly accurate. I mean, it's so simple, but surprisingly accuracy was quite reasonable. This is around 50 centimeters. So probably someday we will get personalized offers also in real stores. Okay, thank you.
So I have a question. When you have detected how predictive our people work, what is sort of the use cases that you foresee that you can use this for?
When you, for example, when you come into the shop, we are using shopping scenario, then you can send human assistant to help. You can also prepare in advance food offers, because it takes some time, and the person don't stop for a long time, so you need some time to prepare this offers and send. So kind of providing better shopping experience. And also it's indicative for shop managers. If you predicted that many persons stop here but they didn't, probably something was wrong. Optimizing of shop and optimizing of health to people.
Another question? I have one question related to this. You use these depth cameras.
Mm-hmm.
So did you have, on the crowded days when there were a lot of people on the shop, did you have problems of picking up the individual people from the crowd of people?
Yes, I don't know how big problem, because we didn't relate it separately, but we have kind of graphical interface which allows to draw tracks, and it shows a lot of nice tracks, continuous tracks, but it shows that some tracks are really broken. But we didn't calculate to certain yet.
Yeah, actually, there are two parts of the question. The first part is the question that you asked for the previous presentation about the training, how much training is used actually, because I think for classifiers you need to define the points of interest, as you mentioned.
No, points of interest, it's no training, it's lazy method.
Yeah.
Nearest neighbors is lazy method. You just searching the data.
But you need to define classes. So how many classes did you use so far? At least you can.
We extract points of interest automatically. So when you follow track step by step, for each point we detect like, okay, the person didn't move from this point for more than half a meter for some time.
This is a point.
This is a point of interest.
Then this time until you reach to identify your points of interest, this is the training time actually.
No, because it's real-time detection.
But you're not identifying all points of interest.
I'm identifying all points of interest and all tracks.
So which is I see as training. Anyway, maybe you're not seeing it as training, but I see it as training because you're identifying them dynamically.
But it's automatically. Training is unsupervised, yes.
But
yes.
Yeah, I agree with that. But still, you're not reaching your optimal decisions unless you have all those points identified in order to classify.
Yes,
correctly.
but it's very fast. It's real time for
Now,
each track.
The second important thing is that your total works about prediction. You're predicting, yeah?
Yeah.
So, are you predicting only the next step? You mentioned shorter track segment or longer track segment. How much time you're predicting in the future? You're predicting just the next step where he's gonna go, or only which next point of interest he will go to?
We predicted only in this block, only next points of interest, and it depended on how much ahead they were found in neighbor tracks. Because, for example, this best neighbor is like 20 minutes long track, and then it shows that next step will be 20 minutes ahead, then it will be 20 minutes.
So you're predicting only the next step, whether he's moving from which point of interest to which other point of interest?
No, I'm predicting for each continuous location next point of interest.
Yeah, next point of interest. For one step, next point of interest. You're predicting next one point of interest.
Next one, yes. But because I tried to predict next one, but then it's not so reliable because previous point of interest very much.
That's the important thing, actually, and you mentioned at the beginning that you were trying to use hidden Markov models. Actually, hidden Markov models will give you maybe, I don't know, maybe more accurate results for predicting future. Maybe if it's about serial more than one step movement, if you use not the first four hidden Markov, if you use 2 4 hidden Markov models or third.
I told that hidden Markov model is not very suitable. Unfortunately, we tried it. For me it was very interesting result. Nearest neighbor is not very intelligent method, but still it was better than hidden Markov models, because for hidden Markov models there are too many points of interest to train model. You need really a lot of data, and there is just not enough data for 2 days, and then layout changes, and so this was more accurate than hidden Markov model.
Yeah, but maybe if you use tweak it a little bit anyway, but you're using that, but you're predicting only one step. That's the answer.
Yes, but the step can be, for example, we compared with other works which predicted. They either predict really discrete locations like 1 out of 33 or something. We predicted like 1 out of 50,000, having very little training data. And also it's not terribly accurate because we predicted with accuracy like 50 centimeters, and they predicted like door or like which shops they go, which is basically door in distance between doors, like tens of meters or 20 meters.
It will be interesting to see the results of predicting the second step, maybe how accurate it was. That would be interesting to see.
For me too, I will try.
Okay, any other questions? Thank you. Okay, so the final presentation of this session is called Novel Categorization Techniques for Liveness Detection, and it will be presented by Peter Matthew from Edgehill University, United Kingdom. And he's a lecturer in games development at Edgehill University and a final year PhD student, and his research interests are in biometrics, liveness detection, autonomic computing, and smart environments.
Thank you. Thank you for viewing this presentation, ladies and gentlemen. As I said, I'm from Edgehill University in Lancashire, and what I'm focusing on in this piece of research, which is part of my overall PhD research, is the applicability of liveness and coercion detection. It's a little bit of both in systems generally, but in this scenario it's with a focus in a mobile environment and within environments such as smart homes, smart areas, and that kind of thing. So what I'm going to cover is I'm going to look at some of the basic mobile biometrics. Some are very common, some less so. I'm going to look at the concept that static biometric systems are becoming more and more mobile in nature. and then I'm going to look at some of the issues that I've come across when I've been doing my classification research into biometric liveness detection and coercion detection. I'll briefly explain what they are, and then there will be the obligatory conclusion. So, mobile biometrics. Currently, there are a lot of biometric devices that masquerade as other things. So most people have a smartphone, they will have facial recognition options within their smartphone. There may be fingerprint recognition options in laptops, in other phones, all these kind of factors. Traditionally, a very, very inaccurate form of biometrics in the mobile environment. It's well known that with some of the early incarnations of the facial recognition, you could break it just by holding a picture of your face over the phone, and it would break the security. So this is something that has happened. This is something that has occurred because traditionally biometric devices are static. They're not very mobile at all. But because of these smart devices, they're becoming more and more ubiquitous throughout wherever you go. And as we've heard in a lot of other of the speeches and presentations today, smart devices and smart environments becoming one of the primary research environments of today. So the poor security has been one of the key issues surrounding these mobile biometric environments, and there has been a limited or lack of liveness detection. What liveness detection is a way to detect if the user presenting the information to the device is living. There's lots of research. There was research done by Van der Poot in 2000, by Matsumoto as well. Some of the key figures within the liveness environment, and they did things like create gelatin fingers so that you could bypass security. Because of this, the liveness detection was born, and devices have become more and more integrated with these features. And the more modern, the more up-to-date version you get, the more liveness aspects are involved, and the more features it can cope with. These aspects have no coercion detection, because coercion detection is a very, very new thing, which I'll talk about in a little bit. So, the future of these static mobile environments was originally the smartphone. That's where the main factor began. But this has changed. There's been a few very relatively recent techniques which use EEG mobile techniques. There are some that use ECG techniques as well, and these are mobile environments using tablets. They're mobile, and they're used an awful lot within the military, within medical care, these kind of areas. And this almost pseudo-smart health kind of aspect is something that is taking off in this case, in the biometric aspect. So there's EEG, ECG, there are things called, there's a device called Sherlock, which is a device that we've been looking at, which is a fingerprint device mainly used in a military setting. And this is one factor that became obvious doing this research and looking into how to classify these different areas. The primary market were law enforcement, military, with a bit of medical. The personal market was still dominated by things like smartphones. Although there are also aspects like the ICANN 100, that is a facial and or iris recognition mobile device that is becoming very, very popular. The biggest problem with that, as with a lot of these things, is it is an extremely resource-hungry system, and it needs a lot of innate power in the device, and it needs access to a very high-quality wireless or mobile service to actually use the data in a meaningful way. So throughout all this, throughout these factors, it became apparent that the static and mobile aspects of biometrics needed standardization. So this standardization, this standardization became the focus of this research paper and the research in general. And it's become apparent through quite a few people within this area that standardization of biometrics in general is an extremely important area. And as the mobile side of it is even more unfocused in this standardization, this has become even more of an issue. And the standardization of these classifiers is what I've been working on primarily. I'm going to look at those in a minute. These classifiers are based around the liveness aspect. Mobile devices in biometrics have very rarely used these liveness factors, and when they have, they've been very poor. The aspects like things like the Sherlock, the ICAM, and the ECG and EEG standards are becoming more and more liveness centric and becoming more and more secure because of it. And the focus of all of this was to make these classifiers relevant to a mobile environment and to make them more secure at a natural level. So along with this classification technique, one of the big advantages that was found out through the research is by providing this increased level of security, by including liveness features within these mobile biometrics, it became easier to incorporate them into pervasive or smart environments because the technology was becoming more and more relevant, because more information was coming out, the standardization allowed a more thorough integration into the overall area. So these factors was broken down and a taxonomy was developed to identify which of these points were most important. And a few of these ideas appeared as the main factors. So firstly, there was universality. How universal was the mobile device, especially within a mobile environment? The amount of device differentiation is huge. Everybody can have a different device. Everybody can have different standards. You have different operating systems, different apps, everything. So the universality was a highly important aspect, along with things like how power worked. How much power did your device have? What kind of resources were there? There may be a limited sample size for your device. So it might be able to take fingerprints. It might only be able to take facial scans. These kind of limitations affected this quite poorly. You then had permanence. Permanence denotes when a sample can change dramatically. It might be due to external influences like noise, humidity, sunlight, excess light, not enough light. And this became an extremely important aspect when considering mobile because of the huge variety of areas it could be in. So these inter-user varieties became a very important area to look at, and it has become one of the aspects that we're going to focus on in a lot more detail. You then have the collectability. How easy is it to gather the data? Again, directly identifying with what kind of power your device has. If you want everybody to use a facial scan, can everything use a facial scan? Does it have the power to use that kind of technology? So how easy was it to use the power? How quick was it? All these kind of factors became important to look at. Then the performance. The performance of these biometrics are normally measured by a semi-set amount of standards. So ERR, which is equal error rate, failure to acquire, false reject rate, these kind of things are all the standards within the biometric environment. However, these standards are not adhered to all the time, and it became a factor that within the mobile environment, these standards were not being adhered to as heavily. You then have the user acceptance. Again, very big aspect. What are you going to accept in this area? Will the users actually end up using it? And in a mobile environment, this became even more important because you are providing this technology in something that a user will utilize every day. So that market integration, if you will, made this aspect even more important to consider and make sure it was relevant to what was being used. And in this, the final classifier in the taxonomy that we've developed is the circumvention of the device. How easy is it to actually spoof the data? How is it easy to get a fake fingerprint, for example, to recreate a fingerprint? These spoof attacks are very common within biometrics, and when you're using something like a mobile device, especially like, for example, a smartphone, you in theory have a direct link to a fingerprint, especially on the phone. So there are some very important considerations with the spoofing that are very specific to the mobile environment. And this also corresponds to things like, what's the performance like? The better the overall performance, the less likely there's going to be problems from things like administrative attacks, all these kind of things. So this was the taxonomy that was developed. This taxonomy was then designed around liveness, but it was also meant to work with the coercion section. The coercion section is something that is a very new aspect. It's very rarely been looked into. And within mobile devices, it's something that very few considerations have gone into, coercion as a biometric factor. And what this means is to see if a user is being forced to authenticate. Are they being threatened so that they will use their fingerprint to let you into a building to access your phone, that kind of thing. How this is done, how can these factors be tested? It's a very difficult area to identify, and it uses things like a way to detect if this happens, things like intentional false authentication. So, if you authenticate with one finger to get into your phone, if you deliberately authenticate with a second finger, a different one, that can mean that you are being coerced into a system at a very basic level. That is an especially useful one within a mobile environment because of the innate things like the touch screen, maybe the iris recognition, these kind of factors. You also have things called tangible key techniques, which are the equivalent of the old panic button. So including those as an app form, as a button on mobile technology, all these kind of factors lead into a very robust environment for mobile biometrics, something that is either seen currently as a gimmick, which a lot of it is in smart devices, or the other end, the very highly technical medical and military kind of environment, and especially law enforcement, use these kind of factors to identify people very rapidly. So these factors culminated by viewing the taxonomy that was made for liveness detection, checking the mobile relevance of it, and then seeing how coercion worked alongside. So these factors all, when brought together, have created the overall taxonomy that is discussed within the paper, and which I've highlighted briefly on, to provide an output of how secure the environment is. Okay, this is the first part of this taxonomical development. The second part has been the development of the actual mathematics behind it and the ways to officially denote if something is being identified as a secure environment or not. So, to conclude, the main focus of this has been biometric environments that are very rarely mobile but are becoming more so every year. Especially, I've not had a chance to look at the new iPhone, but I suspect that will have some more biometric gimmicks in it, and the way we use these kind of mobile environments is becoming a lot more common. And because of that, the liveness categorization needs to be there. If you don't have liveness in your biometric device, it isn't as secure as it could be. Anybody, in theory, you could get a printout of somebody's face and get into their device if they don't have liveness detection. In that situation, all the liveness detection would do is check if you're blinking, check if the image is 3D, etc. And then this, as I said, led on to the coercion aspect, which is the new work which we're working on at the minute, and its development of the new area within this field. All these factors, when coming together, have become a much more attractive proposition to incorporate the biometrics within mobile systems, mobile environments, the pervasive environments especially, by allowing access to buildings more easily, ad hoc access to resources, printing information, these kind of factors. So I know this has been a comparatively quick presentation compared to some, but this is the overall route that my research has been taking. This paper is about. So, are there any questions?
Any questions? So, can you give some examples? Are there any of these biometric devices already in modern, let's say, smartphones or mobile?
Yes, a lot of the Samsung products have facial recognition. There are a lot of downloads that you can get to have apps that will create it's normally facial recognition or fingerprint recognition on smartphones. Facial recognition because it's a much more convenient, you can just look and it's a much quicker process. Whereas things like fingerprints, there's an extra level of process where you have to actively authenticate, as it were. One of the downsides that I haven't gone into in the paper or anything, with mobile biometrics though, is there is the potential security and ethical and privacy issue where people can be authenticated without their knowledge. And there's, whilst not specifically mobile, one of the major issues in biometrics with this was the American Super Bowl, and has been for many years, where they scan the crowd regardless of if the user wants to be scanned or not. So that is an issue, and that, with mobile, because of the ubiquity of it, naturally, it's an issue just as important. So,
what about audio features? Have they been used in this?
There's vocal recognition. Vocal recognition is normally seen as a very poor biometric, especially on mobile, mainly because mobile microphones traditionally haven't been very good. You get what you call noise. Noise doesn't necessarily mean sound, it means data that is interfering with the sample. But in this case, it could legitimately be excess noise, it could be interference from electrical sources, it could be anything. Because of that, the vocal recognition isn't used very much, except within very specific areas, and normally as a secondary standard. So you have facial recognition alongside vocal as a fusion-based platform.
Maybe you mentioned it, but how big was this field version?
Very, very small. There's the research that I've done currently, there's about 4 other papers so far. There's one main piece of research being done into it, and that's very much this is an area to consider. Mainly because liveness has been such a all-encompassing area, a very important area. Nobody's thought of, as it were, the next stage along, and the coercion is the next question after the liveness standard. But yeah, very little research being done into coercion. So within that, hopefully, that's why I want to get the taxonomy within coercion, because it starts off as a standard as opposed to having to go back and get people to work into the standard.
More questions? Thank you.
This is the last presentation, I think, that I have today. So first, I want you all to thank Arto for his good presentation of the class today. And thanks for all presenters today. For we have a very, I love this session very much. It was very good, actually. I just want to point out, tomorrow we're starting at 9 by our keynote. Professor Tim O'Farrell. It will start 9, so please make sure you arrive before 9 here. And this evening we get for you to Oxford, so it's going to be a free evening in Oxford. Yesterday we went with Professor Khaled to Oxford, and it was very nice. We found that there was a big party in Oxford.
We can't promise the party tonight, but just a big party. But yeah, the weather is guaranteed, so we work very hard to make the weather good for you. So I hope you will enjoy the evening in Oxford.
Thank you very much. Thank you. Julia, you're the first presenter tomorrow.
Yeah.
And Marco, where's Marco? Marco, I think he was here. He's the chair session. No, tomorrow on the break. Julia and we have Simon? So Simon and Abdulhak Bubitra, yeah? Yeah. So you're presenting tomorrow. So bring me your presentation in the coffee break, yeah? Tomorrow after the keynote, give me the presentation tomorrow. And thank you very much. And your chair will be Mark.
Actually, about YouTube streams, I went into live stream, but I saw some static pictures, but I couldn't update.
You can't live, it's live. I think it's live, but the guy who is working it is downstairs. Yeah, it's one pause live. I'll show you what it is. Nice presentation. Actually, I've got too much time to ask all the questions that I have. It was very good because the work is very interesting. Yeah? Because I'm an expert in about models and how to close tweets. I mean, I read the paper, I know that list some parts. Mention those parts in the paper, so I would prefer to have mentioned it. More clear about where you did those observations. And the 2 seconds, well, they were asking about the screen that it's easy, trustworthy.
One question which comes to my mind is that in your source information about